All right, so good afternoon, everyone. Welcome to the Bokeh and sort of Bokeh adjacent tutorial for SciPy 2016. My name is Bryan Vandeven. I'm really happy and pleased to be here. I've given some talks about Bokeh at SciPy before, but this is my first tutorial, so I'm really excited to be able to go into a little bit more depth about some of the features and things that have been going on as well. I'm here with James Bednar as well. He's also going to deliver some of the content today. We're going to be talking about both Bokeh as well as some other related projects that interact really well with Bokeh, Data Shader, and HoloViews, and some new GIS features as well. So he will be delivering some of that content. Just a word about the scheduling. Probably hard to see, but it's up here on the whiteboard behind me. We have 4 hours here. First hour we have setup. Chapter 1 and 2 we'll talk about charts and plotting. Chapter 2, or hour 2, we're going to talk about styling, layout, and interactions. We're going to take breaks in between each of these hours. Chapter 3, Jim is going to take over. He's going to talk about some GIS and Data Shader, exciting sort of things there. And then the last hour, we're going to split between HoloViews, which interacts really well with Bokeh, as well as some examples in practice with creating some Bokeh server applications, which are the newest, one of the newest fun things that goes on with Bokeh this past several months. So I guess before we get started, like I said, let's take maybe 5 or 10 minutes, make sure everyone is set up. If you go through this README on the Bokeh Notebooks website, at the bottom you'll sort of see a check that, let me go to the actual intro notebook, sorry. If you load up the intro notebook from the tutorials directory, then at the bottom there's some sort of quick checks here that you have everything installed. So you can import IPython, you can import Pandas, you can import Bokeh, and you can check those versions. They should be roughly something like that. So Bokeh 0.12 is what you want today. Pandas, maybe not that new, but 0.18, 0.17, something like that. And a recent Jupyter notebook as well. So we'll just take 5 or 10 minutes, make sure everyone's set up, and then we'll go ahead and dive into some of the content. If you look at this index notebook, there's a nice table of contents here at the top. As you can see, there's more content in there than we're going to be able to cover today. So there's actually a lot of content for the tutorial. We're going to go through the first 4 chapters, and then we're going to sort of take a smattering of topics from the last several chapters, again, just because there's way more than 4 hours of material here. So encourage you, if there's something else you want to dig deeper into, just be aware that these notebooks are available, and you can certainly run through any of these topics. Some of the things that we're not going to get to today are things like the very low-level model API, and probably we may or may not get to some of the annotation stuff. If we have time, we'll dive into that as well. That's some new stuff, but we may not have time for it. So quick questions while everyone's getting set up. So who's used Bokeh? Quick show of hands. Okay, great. So we're going to start, like I said at the beginning, but we're going to get pretty far in this tutorial. So it sounds like there's a lot of folks here new to Bokeh, so that seems like a pretty good plan. Has anyone here had a chance to play around with, for instance, Data Shader or HoloViews as well? A few folks? Okay, great. Well, James is going to have some really great information and some exciting things to show you that I think you'll be interested in seeing. Like I said, beyond that, let's just take a few minutes, maybe another 5 minutes or so. If you have any problems, please raise your hands, holler at me, and holler at James, and we'll come take a look. Also, just by the way of mentioning, static rendered versions of all of these notebooks are available on nbviewer.jupyter.org. If you go there, there's a Bokeh link here. You can click on that, and there's actually a higher level notebook that has a quick start, some more information, some small gallery, as well as the link to the tutorial, which has that nice, again, table of contents and all of the rendered versions of these notebooks. So obviously, if you want to run the exercises, you have to download notebooks locally and actually execute them on a running Jupyter kernel. But if you just want to see them rendered, they are there on NBViewer. All right, well, I don't actually see anyone raising their hands having problems. So actually, on that assumption, I'm going to go ahead and just say maybe a few introductory words, and then we'll dive into some Chapter 1 exercises and content. Yes?
The instructions, I think we were using Python 3.4.
Yep.
3.5, so is there something that doesn't work on 3.5, or just that?
We run our continuous integration unit tests on Python 3.5. We don't run our entire test suite yet on Python 3.5. We're just resource limited on terms of Travis, but it should work fine with Python 3.5. I'm running Python 3.5 on this demo account today, so it should be fine. Yeah, so just also to mention, Bokeh support on Python 2.7, Python 3.4, Python 3.5 probably works on Python 3.3 too. We just don't test it on Python 3.3, so we don't claim any official support there. But should work very well over a wide variety of Pythons. Actually, someone recently came and made a pull request to make it work better on SciPy. If anyone uses SciPy, there should be some limited functionality there as well. Okay, well, let's go over just a few introductory words as long as we're waiting. So, what's Bokeh? Since there are a lot of folks here who haven't used Bokeh, I'll just go ahead and mention. So Bokeh is a library for interactive visualizations and for creating data applications in the browser that are driven by, the Python data analytics stack. There's a huge explosion of tools in Python for data analytics in the last 5, 10 years. And so it's really nice to be able to sort of connect those tools to great visuals and data applications. And so, you can create standalone HTML documents. You can create these server-backed apps that directly connect things, like Pandas and scikit-learn and all of these great tools to these interactive applications in the browser. It's capable of very versatile graphics, as we'll see, very flexible, very composable. We also have some facilities for streaming data, for large data. You'll see the large data example here with Data Shader today. And there's also other language bindings. So, Python is fantastic, but there's a lot of other languages people use as well. So there are Scala and R and some currently maybe not maintained Julia bindings. If you know some Julia and you're interested in maintaining Bokeh.jl, please let me know. We'd love to get someone to help out with that again. But it's easy to write other language bindings for Bokeh, and so we try to encourage that whenever we can. But of course, the most important thing is that we want to have these data applications or these visualizations in the browser. We don't want to write JavaScript. I mean, I don't like writing JavaScript. And I have to do a lot of it, but hopefully that's so that you don't have to. So that's sort of what we're getting at. Just as a quick example, before we dive into the details, Bokeh works really well in the IPython Jupyter notebook. And basically, to use it in the notebook, we're going to use this output notebook function. So here from Bokeh.io, I've imported output notebook and a show function. So you import output notebook, and if you're actually in a running notebook, you should get a nice indication that it's successfully loaded. And then beyond that, there's a couple of different levels of APIs. There's a high-level charts API, which can do some statistical kind of charting in sort of one-liners. Like in this case, we want to get a histogram, split out across different things. It's just a one-liner. There's also this possible to create sort of much more flexible and interactive type graphics as well. So this is a reproduction of Hans Reising's Gapminder sort of demo from his TED Talk, and it has this nice slider. And this doesn't require a server or anything. This is actually just a pure HTML and JavaScript document that I'm able to scrub this slider and sort of see it evolve over time. And so that's the sort of thing we want to let people do with Bokeh as well. And then finally, we want to enable apps. And I'm actually not going to load this here. I'll just go to the site. If you go to demo.bokehplots.com, you can see actually a new updated gallery with lots of different examples of the kinds of Bokeh server apps that we want to be able to provide. So these are really an ability to connect actual Python data analytics tools, things like scikit-learn, scikit-image, pandas to Bokeh web applications. So here's an example of this nice cross-filter tool. So I can load this up and I can see some data and I can slice and dice. Maybe I want to, miles per gallon versus miles per gallon is not too interesting. Miles per gallon versus weight, maybe I want to color it by the displacement, and maybe I want to change the size equal to the acceleration field, and we can have that sort of interaction here. Here's another one. Here's a reproduction of the R Movie Explorer, but we've done it in Bokeh, and this is not much code to create this kind of deployable application, right? So here we can filter by genre and have this nice selection. So we'll get to some of these types of things at the very end of this tutorial today, but just want to give you an idea of where we're headed. Okay, so any questions though before we go ahead and dive into actual tutorial? Hope everyone brought a laptop. Yeah, question? Can you just make it a little bigger? Yeah, absolutely. Oh, sorry. Yeah, sorry. It's a little bit less resolution than I was expecting, unfortunately. How's that? Is this okay for font in the back, or is it still too small? Okay, please let me know. Interrupt me anytime. Still small? Okay.
Can we dim the light?
Yeah, that might help, actually. Let's try that first. I'm going to run out of space here pretty soon. Nope. Okay, well, I'll just go ahead and make it bigger. We'll see. I might sort of go in and out, depending. Okay, so any other questions, though, or comments before we get started? Great. Okay, so from this intro at the top, there's this nice table of contents. Again, we're going to start with chapter 1 here, high-level charts. I hope you're ready to do a little bit of coding. We're going to go ahead and practice some things. So Bokeh takes a deliberately layered approach to interfaces. At the bottom, there's a very low-level sort of API called models. This layer is basically a one-to-one correspondence between some classes on the Python side and classes on the the JavaScript side. And we want to be able to keep those in sync automatically. And so this is the most flexible layer. You can put these building block pieces together in whatever way you need to in the most flexible way possible. But of course, it's also the most verbose. And so we're not really going to talk about that much today. The next level up is Bokeh.plotting, which I would sort of describe as roughly the same verbosity as MATLAB or Matplotlib. And we're going to talk about that today. But first, we're going to talk about the highest level interface, which is Bokeh.charts. And so the idea here is if you're really doing something like exploratory data analysis, you want to get a quick look of your data, you want to get sort of the most out with the least amount of code, Bokeh.charts is what can do that for you. And so let's take a look. So I'm going to start out with, again, some fairly standard imports that we're going to use in the notebook. So from Bokeh.io, we're going to import output notebook, which is what lets us know that we want to see our plots inside the IPython or Jupyter notebook, and the show function, right? So I can execute that. We can see that Bokeh.js successfully loaded. By default, Bokeh.js is loaded from a CDN, a content distribution network from the web. And so that goes ahead and installs Bokeh.js and makes it available for us to use. So the first thing we're going to do is maybe we want to do a scatter plot. It's pretty common to want to create a scatter plot. So let's take a look at the standard iris data set, right? So this is a bunch of data collected about various properties of some irises, 3 different species, Setosa, Virginica, and I forgot it. It's down here later. Anyway, we'll see it in a second. And then it's got some measurements about the various lengths of the petals and the sepal lengths and sepal widths. And so we might want to plot some things about that. So let's see how we do that. So from Bokeh.charts, we import scatter, capital S scatter here. And then we simply call scatter, right? So we give it the data frame. So in this case, flowers is this data frame that has all of this table of information. We pass that in and we say that we want X to be the petal length and Y to be the petal width. And sure enough, we execute that. And I need to actually import the data, sorry, up here at the top. And then we execute that and we get a nice scatter chart. And so this is a Bokeh plot directly in the Jupyter notebook. And so it has all the standard tools that you might want. You can pan and you can use your wheel zoom if you want. And there's a box zoom over here as well, and we can reset things. There's also a nice save tool. Save tool, by the way, if you're familiar with the old save tool with the pop-up dialog, is now streamlined a bit. It will directly open a download dialog in browsers that support it, and it'll just open up a new tab here in ones that don't, where you can download from this tab as well. So it's a little bit nicer, I think. So anyway, that gives us our scatter chart, right? So that's fairly simple and straightforward. We might want to customize that, though. Right, let's say that we want to, color by the different species. It looks like it's versicolor, was the last species I'd forgotten. So in this case, we can take the same exact scatter line that we had before, but we can add a keyword argument for color, and we can say that we want to color by the species column, right? And we also maybe want to have a legend. Once we've added color, we might want to have a legend. So I've also added this line, legend equals top left. And let me make the text bigger here, because I just realized we probably are not big enough. And so then we go ahead and execute this line. And again, we create our plot, P equals scatter, and then we call show in the notebook, and that's what actually causes the plot to be shown below. And again, all the standard sort of tools are there. This is the sort of thing at the lowest level that you'd build up piece by piece. I want to add this tool, I want to add that tool. Bokeh.charts tries to take away some of that burden to do some of the statistical transformations for you, but also to create sort of a reasonable default plot for you. Yes, question? No, so it's questions about saving output. Currently you can generate HTML files that you can send an email because they have embedded JavaScript, and you can save a PNG. We have a possible path forward on SVG output. This is actually a surprisingly tricky and difficult proposition for getting things out of a web browser in a way that's happy. And so it's on our radar. It's been on our radar for a long time. It's just sort of a difficult proposition, but we are working on that. We have, I think, an SVG path forward that was discovered by Sarah Bird, and so we're going to start trying to implement that path forward pretty soon. Okay. So anyway, so that's the first example scatter. Now we come to our first exercise, which is where you guys are going to jump in, which is that we want to not just vary the color, but maybe we actually want a different marker shape for all the species, right? So here you can add a marker keyword to that scatter line, saying something like marker equals species, and you should be able to see different markers. So I will let everyone try that. We'll take just a few minutes, and we'll compare results.
So assume you can also choose which markers in some way, or is that?
So yes, the question is about being able to choose the markers, and I would say this is an area where that layered interface comes into space. There are a lot of different markers available, and at Bokeh.plotting you have complete control over what markers you want. At this level, the idea is really to sort of do a lot of stuff automatically or automatically. And so it's possible that we might add some features for exerting a bit more control over the markers. Currently, it just cycles through a list at the Bokeh.charts level. Good question.
if anyone is not able to run the preceding cells, let me know and I'll come help make sure that that everything's installed. And,
Maybe just another minute or so, and we'll talk about this quickly, then move on.
You mentioned that up front when we did the import, that it was actually pulling from the CDN. Is that always the case? It will pull from your local?
You can use inline resources. In fact, that used to be the default. So there's a way to use what are called inline resources, which actually just loads the Bokeh.js code from your installation of Bokeh locally and basically puts it inside an output cell here to make it available. That actually used to be the default, but we got a fairly strong request and pushback from a lot of people to make the notebook small. So that makes the notebooks bigger, right? Because then all of the JavaScript for Bokeh.js is actually right in the notebook as opposed to it loading it. So you absolutely can do that. The way you would do that is something like this. While we're waiting, I'll write some notes. You would do something like from bokeh.resources import inline. And then when you do output notebook, you would simply pass that to the resources argument. You would do output notebook resources equals inline, right? And so then it won't do that CDN thing. So if you, the nice thing about that, although it does make the notebooks bigger because the JavaScript code is literally embedded in the notebook, is that they're completely transportable. You could ship them to someone, or if you're behind an air-gapped network or something like that, that's fine. There's other modes too. If you want to load from like a local server, like behind an air-gapped network, that's certainly possible, but a little bit more of an advanced configuration. Okay, so let's talk about this scatter example. Again, I just basically copy and pasted the code above. What I added here was this marker equals species. Note that it's possible to add some of the continuous columns here. It's going to do a segmentation of them. In this case, you get like a lot of different categories. Typically, you probably want to put marker varying over like a categorical column. But in this case, I've done marker equals species. And sure enough, you can see that I get not only the color variation according to the species column, but I get this marker variation as well. So I get red circles for Setosa, and green squares for versicolor, and blue triangles for Virginica. All right, any questions about that before moving on? Cool. All right, so next thing, another high-level chart that's pretty common for, sort of exploratory data analysis or getting started, or bar charts, right? So again, in this case, we're going to use the AutoMPG, or it's also sometimes called MT Cars dataset, right? It's a bunch of data about various makes and models of cars that has information on their horsepower, displacement, weight, acceleration, the origin, things like that in their name. So let's go ahead and import the bar chart from Bokeh.charts. From Bokeh.charts, import bar. And again, this takes the same sort of format. It's very data frame centric. So the Bokeh.charts API is very centered around pandas, but the rest of Bokeh does not require pandas, but Bokeh.charts does require pandas. So it's an optional dependency if you want to use Bokeh.charts. Most of the charts accept pandas data frames as the first argument. Pandas is not required for the rest of Bokeh, just so you know.
Another question
Yep.
relative to all that is it possible to save the notebook with the embedded graphics or not?
Yeah, absolutely. So for instance, if you go to the Jupyter or nbviewer.jupyter.org and you click on that, you'll see notebooks that render. It's very contextually dependent. For instance, the notebooks on GitHub do not render with Bokeh plots because GitHub scrubs all JavaScript, right, for presumably security reasons. Yeah, it should show up. Yes, absolutely. Yeah. So it saves it with. So if the CDNs, it'll have to load from CDN if you're using the default CDN resources. And so if you want it to load without network access, for instance, you'd want to use inline resources. But yes, otherwise it will load.
Also, if you save it as HTML, you can do it locally.
Yeah.
It'll see it.
Yeah. Yeah, we can talk afterwards too in the break. Okay, good questions. Okay, so bar chart again, very common for just exploratory data analysis. Quick looks at your data. In this case, you pass in a data frame and you sort of give it, what do I want to label the axis with? What values do I want to take? But you might also want to do an aggregation, right? And so in this case, we're doing an aggregation max, and so we want the max miles per gallon by cylinders. We don't want a legend in this case. We want to add a crosshair, so we've got a bunch of options for things like that. And so if we execute this cell, sure enough, we're labeled by the number of cylinders here at the bottom, and the aggregation here is grouping by the cylinders and giving us the max miles per gallon for each group of cylinders, right? So we can see that all of that is done there. So what else might we want to do? Well, we might want to group things. So instead of just having one cylinder, we might actually want to group by the origin, right? So we want the median miles per gallon per year, but we also want to have that sort of grouped visually by origin. That's really straightforward to accomplish here again. We add this group keyword. So you can see I've pretty much done the same thing as before, although now I've taken median as my aggregation. But I'm going to group by origin, and the plot that gives me is now this group bar chart, right? Where we can see for each year, actually in this case I labeled by year, for each year we have a group by origin, 1, 2, or 3, which I believe are North America, Europe, and Asia, or the 3 codes for the origin, which shows the median miles per gallon for each one. So we get this nice group bar chart. And I should add that lots of these different visual properties of the chart, the colors, the bar widths, all that sort of thing is configurable as well. We're just going to get into some of the basic stuff at this tutorial today, but you can see that. So the last thing here, though, is what if we want to stack? Maybe we want to have a group bar chart, maybe we want to have a stacked bar chart. That's fine. There's a stack parameter, and this will be the next exercise. I will leave this to y'all to try. So that's the next exercise. We'll take another minute or two. Again, you should be able to start with the code from the cell above for the group bar chart and change it just a little bit to get a stacked bar chart. Yep. Yeah, so there are tooltips, and there is some support for that with Bokeh.charts. We're going to keep increasing that, but definitely the sweet spot right now for tooltips is using Bokeh.plotting, and we'll show some of those examples later. But it is possible to add hover tooltips to some of the Bokeh.charts, but let me defer that question because that's a little bit of that support is still ongoing. But definitely with Bokeh.plot, you can have very customized tooltips with customized templates that embed images, and I think you can actually embed other plots. I'm going to try that soon, as well as any fields from your column data source that you want. So we'll see some examples of that. That's a good question. So I didn't work very much on Bokeh.charts. I know there was talk about that, and I'll have to go look back and see whether that support was added. Right now, I know there's standard sort of pandas aggregations, max, mean, median, min. I believe there is an issue to talk about adding what you've described, and I don't believe it's been implemented yet. So we'll have to, maybe at the break, I can look up in detail. Okay.
So you had mentioned that pandas was not a dependency.
Pan For Bokeh.charts, yeah. So for Bokeh.charts, right now, it really expects a pandas data frame for the first argument. If it's possible that we could look into ways to expand it, I'm certainly not opposed to that. It's just Bokeh.charts is the newest API. It's probably the least mature, and it has reached a level of stability now that we had an experimental phase, and now we're sort of settled on some things. It's definitely not pandas data frame is not required. For standard Bokeh.plotting, you can use Python lists or NumPy arrays or pandas columns, whatever you want. It's possible we could think about adding support for other things besides data frames, but that would be work at this point. Right, good question. Oh, question, yeah. Good question. So I believe that's specifiable as well, but I don't know offhand, again, so we might have to dig into that. Maybe we'll come back during the break and I can try to dig into a deeper answer for you. There might have been an issue that was about this as well that might have been resolved recently, so let me get back to you on that. I can find that now. Yeah, I agree. That's a little weird. And if there is an issue for that, I'll make one after, after this tutorial. Okay, so just to give you an idea of what I've done, all I've done is I changed the group to stack. So instead of grouping them, I want to stack them by the origin. And sure enough, we get a stacked bar chart. So. In this case, by the way, I've added a crosshair to this tool. There's this nice toolbar over here. If I want to turn that crosshair off, I can certainly click this and get rid of the crosshair. Easy enough, just to mention that. Okay, another common chart that we might want for quick looks on data is histograms. So here, I'm actually going to synthetically generate some data, right? So I'm going to use NumPy random and log normal. I'm going to create two different distributions, basically. So I've got a normal distribution, a log normal distribution. I'm concatenating both of those columns into a pandas data frame here with this line right here. Looking at some of the data frame, we can see that the data frame is such that it's got a type column that describes what distribution that value was pulled from, and then the actual value that was pulled from that distribution. So it's two columns, type and value. And so we want to create a histogram. So again, from Bokeh.charts import histogram. And then we can go ahead and call histogram. And sure enough, we give it a data frame as our first parameter there. We give it a values keyword argument that specifies which of the columns we actually want to bin. And we can also pass on some parameters to the histogram function that gets used. In this case, we say we want 30 bins. And so I can execute this, and I can see, sure enough, actually create my data frame. I get for having pre-executed notebooks. I forget which cells have been executed. So there we have our nice histogram. Now, of course, this is binning all the data, right? Both the normal and the log normal data together, right? So that's one thing to consider, just the way I've written it so far. But what we might want to do is to, of course, we have multiple sort of distributions, so we might want to actually group by that type column and get different histograms for each one. So that's the next exercise. There's instructions here. What you can do is you can pass in a color keyword argument, and you can specify which of the columns you want to group by. In this case, you want to group by that type column, and I'll let you try that. Yeah, so I actually would like to go make a visual refresh. We've had an opportunity to sort of do a visual refresh on a lot of aspects of Bokeh, but I'd like to go through and redefine some of the, maybe the defaults for charts. We do have several built-in palettes, though. We have all the Brewer palettes. We just added Viridis and Plasma and some of those other new color palettes as well in the 0.12 release. And I believe those could be used with Bokeh.charts as well, but we'll see some more examples of palettes with some of the Bokeh.plotting stuff. The standard palette now is sort of this red, green, blue thing, and I think it's maybe could use a little bit of attention from someone with better design sensibilities than I have. Okay. Question? In this case? Oh, you mean visually? No, I think that's a small bug in this chart. So I actually noticed that earlier today. I think there's just a little bit of fixing we can do. So I'm going to make an issue to investigate that. Certainly, if you're doing stuff with Bokeh.plotting, I hadn't noticed that before, so there may be something in here that's just causing a little bit of overlap.
That toolbar is now on the right, and it has shrunk the size of the plot very slightly.
Okay, yeah. So yeah, so there is a little bit of, I would say, on some of these high-level charts, there's a little bit of a visual overlap, especially with some of the bar charts where they're close together. So we're going to investigate that. Okay. All right, so what did I add here? So I added this color keyword argument. Again, we want to create different histograms. We want to differentiate them by color. And the way we want to do that is to look at the type column and group things by the values in the type column. And there are two values. There's a normal and log normal. So sure enough, we look at our, once I add color equals type, we see that sure enough, there is green is the normal distribution and red is this log normal distribution. We can see histograms for both those at the same time. Great. All right, last example here in Bokeh charts. And I should mention there are other kinds of charts that are available. We're only going to go over these 4, but there are also a horizon chart, a recently added chord diagram, as well as I think a time series chart and some other ones as well. So this is actually a great place to get involved, by the way, with Bokeh development. If you're interested in finding an open source project to contribute to, adding new high-level charts is a fairly self-contained sort of development aspect of Bokeh, and we'd love to get more high-level charts added, contour charts or quiver plots sort of at a high level. So if you're interested in getting involved, please let us know. We'd love to help. We always try to be very welcoming and help anyone get involved with development. Okay. Last example, though, here is box plot, another sort of statistical chart we want to do to examine various distributions of data. Let's go back to our flowers data set. In this case, it's very similar to the chart we saw before. We want to label, what is the label on the x-axis, and then what do we want to take the values from to create the distribution for our box and whiskers. And so sure enough, in this case, we want to label by species. We want to create, this box and whiskers for the distribution of values of petal width. In this case, we're adding a crosshair. We want to specify a fixed color for all of the boxes and whiskers, so we can do that. We can give X label and Y label to let us know, label axes as well as a title. And so if I execute all this, sure enough, we see that here. Now, of course, the legend here is not so useful because we colored everything with the same color. So, typically you might actually want to color by one of the columns, right? So let's go ahead and do that as an exercise. So we're going to we're going to keep this color parameter, but we're going to tell it to color, for instance, by the species column. So I'll leave that as an exercise for you. Take a minute or two. Try to stack that so that everything is visible on this sort of narrow screen.
Was there a particular reason why you chose X label?
In this case, we could certainly, no. Just whoever wrote this example decided to do that. I'm not sure. I mean, we could certainly put species there. Oh, or specied. Species. I think in this case, just because the labels were a bit large, the sort of the text strings are kind of large, and so maybe they just wanted to save space. But and maybe they thought it was self-evident that that's what those were. But you can certainly add X label equals species there, and it works really well. Cool. Oh, in the IPython notebook, I just hit enter. So here, I went over to tools, and then I just hit enter, and it automatically lines up. Yep. Okay, so the change that I made was to the color parameter. So before we had given it a fixed color, just a hex string for color. In this case, I changed it to the name of one of the columns in my data frame, and so it automatically groups by the that values in that column and colors according to that column. And we can see the result here, and so now our legend is hopefully a little bit more useful than it was before. Okay, so again, there's lots of examples. If you go to, I see those links are a little bit out of date. If you go to the examples charts file directory on GitHub, you can see lots of examples there. There's also a how-to charts that has sort of a more conceptual description of some of the high-level sort of statistical things that some of these charts do. And of course, we have some demos here. So any questions about charts before moving on to chapter 2? And then we'll take a little break after chapter 2. All right, you guys are quiet. Everyone have a food coma from lunch? Is that all right? Okay. All right, so we'll go back to our table of contents here. The next chapter 2, is basic plotting interface. And so this is sort of my sweet spot. I spent most of my time. This is sort of one of the earlier interfaces, and I'm probably most familiar with this one. So hopefully, if there were questions about the last one, hopefully they have a little bit more certainty and certitude when I speak about this interface. Again, the same sort of standard sort of imports apply here from Bokeh.io. We want to import output notebook. We want to import a show. The one thing to note here is from Bokeh.plotting, we want to import figure. So this lowercase figure is basically sort of the starting point for any of the things you might want to create using Bokeh.plotting. So the idea behind Bokeh.plotting, the central sort of idea, is that you can have all of these different kinds of graphical or visual shapes that you want to display, like circles or other kinds of markers or rectangles or quads. And the idea is that for any of the attributes of these visual markers that we call glyphs, you can attach either a fixed value, like x equals 10, or you can attach x to a column of data, right? I want to set my x position to be, this column of data or this list of x positions. I want to set my fill color to be equal to red, or I want to set my fill color to be equal to this array of colors so that every single circle or rectangle that gets drawn has a different color. So that's the basic idea. Every visual property of one of these glyphs can either be a fixed value or it can be a vector of values. And so we'll see that in action. But around these glyphs, Bokeh.plotting also creates a very sort of nice default plot, has a nice default set of tools and a nice sort of standard layout. All that's customizable, but it sort of tries to create a nice default plot for you. Okay, so let's take a look. Let's take a look at a basic scatter plot using Bokeh.plotting. Not really any more complicated than with charts at this level. So we create a figure. Let me make this font bigger. That's got to remind me. P equals figure. In this case, I want to be able to specify a width and a height for the canvas, so I can pass those in. And here we can use whatever kind of data we want. We can use Python lists or NumPy arrays or a column from a pandas data frame or really anything we'd like. In this case, I give it a circle. I give it some x and y positions. I give it a fixed size. I give it a fixed value for the line color and fill color, in this case sort of navy and orange, and then I give it a fixed fill alpha as well. And so that gives me this plot object back, and now I can show it. So I call show, and I don't think I actually ran my imports above. There we go. I'll put notebook, and I actually want to run that. There we go, right? So we have exactly what I asked for. We have these circles at these x and y positions. They all have size 15. So size is in screen units. There's a different option, radius, if you want to use data units, but size is typically in screen units. And we've got, again, navy line color, orange fill color, and we have this nice fill alpha that's sort of semi-transparent. And again, this comes with standard sort of tools. We can pan around. We can invoke our wheel zoom or our scroll zoom. We can hit the reset and get back to where we started. All of that works fine. It just comes out of the box. Again, just to mention things like, a single value. If I want to go here, I could say something like y equals 6. And if I do that, sure enough, they're all going to be at 6. So again, any of these attributes, things like position, things like fill, or line or text values, text properties rather of the glyphs, can take either a single value or a column of values. So that's sort of one really important point to keep in mind, and you'll do really well with Bokeh.plotting. Okay, so all of these, yeah, question. So you can pass a column. So for each of x and y, so these take list sequences of data. X is a sequence of data, y is a sequence of data, so you could pass a column from a pandas data frame, or you could pass a NumPy array, you could pass, again, a Python list, but not a full data frame, typically. Question? Good question, I don't know. I think so. I think anything that would be iterable, I think would work. We're not going to it won't call a function for you, if that's what you mean. But if you called a function that returns some kind of iterable sequence, whether it's a generator or something like that, I think that would work fine. Yeah. Cool, good questions. Okay, so as I mentioned, size is in screen units. So here if I change size to something like, 35, we can see, sure enough, bigger things there. The reason you can tell that they're in screen units is because if I zoom in and out, right, they don't get bigger or smaller, right? They stay 35 pixels big, regardless of the zoom level. So that's screen units, but we also have this radius for circles in particular, which is a way to set things in data units. So let's go ahead and have that be our first exercise. So take the code above. We want to change the size parameter that we pass to circle to be a radius. So let's take a look at how that behaves. Going to bring up the lights just a little bit for the recording.
Is that okay?
Is that good in the back? Okay, great. Yes, absolutely. Yeah, absolutely. We'll see that in just a few more. Absolutely. Yeah, you can add as many as you need.
So radius is in data units?
Radius is in data units by default. You can actually configure that either way, but the default is that size is in screen units and radius is in data units. So let's take a look at what happens. If we just keep our original value of 15, we get really big circles, right? we can certainly zoom out and we can start to see that, oh, sure enough, they are different positions and they overlap quite a bit. So let's try something like 0.5, a little bit more reasonable. And so we can see that, these, sure enough, these have a radius of 0.5. And if we zoom in and out, they get bigger and smaller. That's how we know that they're really in data space units there. So that's, fairly good to know. Other markers that exist, circle, has this size and radius. Most markers just have X and Y in size. We can see that there are square, things like squares as well. In this case, I've created squares. I've given it X and Y positions. But notice here that now I've given it a vector of sizes, right? So like I said, every attribute can have either a fixed value or it can have a column of values. Yep. And so here I've given it a vector of sizes. And so all of the sizes of those squares vary. I've also given it this color argument. Color is sort of a nice convenience. It sets line color and fill color at the same time, is all that does. And then alpha is the same way, sets the line alpha and the fill alpha simultaneously. And so we can see we have these nice squares here of different sizes. And I think there's a question over here.
You want to define a new figure with every cell?
Not necessarily. For the purposes of this tutorial, it's nice to have a new figure. So the notebook interaction is a little bit weird with Bokeh, right? Because it's possible to actually update figures that are up above, right? And we can maybe talk about some of that in the interactions. We have this push notebook capability. But if you want a new figure, then typically you'd want to call a figure in the cell, and you would get an output below. You can certainly build up a figure over multiple cells. You could create a figure and then have several cells that add markers or glyphs to it, and then show it in some other cell. That's fine. You could even create multiple figures in one cell and then show them in different cells. But there's a lot of different configurations. It really depends on what you want to do, I guess, would be the sort of the short answer. Great. Okay. So here again, just as a reminder, if I change this to a single fixed value from this vector of values, if I change this to, for instance, 20, sure enough, we get the same size squares, right? So again, very, very sort of foundational concept for this Bokeh plotting interface. Every visual attribute can take a vector of values or a single value. Yeah.
So if the size doesn't have the same length as the actual data, will it loop? Or
I'm sorry? Oh, I see. No, so you want to have them have the same amount of data. I think you're actually going to get a validation warning there. I thought you would. So it's actually going to leave that off, so that's not good. It depends on what you want. There's not really a right answer there. So some people would say it should loop. Some people would say that doesn't make any sense for my use case. So it's, I'm not going to necessarily defend this, but I'm not going to criticize it too much either, because it really depends on what you want. The behavior now is that, and there's an implicit assumption in what these things that are called column data sources that I'll talk about in a bit, that all the columns are the same length, right? The only thing that gets broadcast are these single values. So if you give a single value, it's broadcast across the length of the rest of the columns. But if you give another column that's not the same length, it's going to take the sort of the shortest. Good question. Thank you.
You may have already said this, but what's the keyword to use data units for your size instead of?
So you can just specify size underscore units. Yeah, I haven't specified it. Size underscore units equals data, I believe. Let's double check. Like there. Oh, interesting. Maybe I really thought you could specify the size units in data. It's possible you can't specify the size units for this marker because it's a scatter marker. A lot of the other things like circle, I know you can change like the radius units between size or screen space and data space, but because these are really intended to be scatter plot type markers, I think they're mostly in data units. So that's interesting. I thought that might have been something that used to be done. I'm not sure. It may have changed. Yeah, good question. A lot of the other positions, or a lot of the other parameters for a lot of the glyphs, like X and Y, you can specify X units or Y units, screen or data. So, okay. A lot of different markers that are available, so you can see things, asterisks, diamonds, triangles, X marker, squares with, X's or crosses through them. So very easy to create any of those different markers. So we can just go ahead and try plotting some different markers in this cell. So let me go ahead and copy some code here. I'll let y'all play around with this as well, but let's go ahead and I'll do this, circle, or rather asterisk. And let's maybe copy this one here. I'm going to go ahead and do 2 at once, just for good measure. Oh. Those are all on top of one another. Mix those up a bit. There we go. Make those a bit bigger. All right, just to talk a bit about what I did for this exercise. So I went ahead and added 2. So there's no reason you can't add as many of these glyph functions, glyph methods rather, as you want to a particular figure. In this case, I sort of changed the square into an asterisk, and so we get these sort of red asterisks. I changed circle above to circle X, and we can see that we have sort of the circle X markers as well. So it's perfectly fine to add as many of those as you need. For instance, if you want to vary something by color, depending on what you want to do, it might make sense to have one marker that has a color field where you actually send the colors for each marker on the one glyph, but you might want to have different glyph functions where you just configure each one with a single color differently. It just really, again, depends on what you're trying to accomplish. Okay, any questions about sort of the markers, scatter markers in Bokeh.plotting? Okay, all right, well, we'll go pretty quickly through the next few sections here and take a quick break. So the next section, basic line plots. As you can imagine, we need to be able to draw connected points, not just points. So there's p.line, right? So in this case, we can give it a series of values for x and y positions. It's going to draw a connected line through those points. We can give things like the line width is equal to 4, and we can say something like the line alpha, equals 0.2 to get a really heavily alpha line right there as well. We can give line dash. Go down to the next line, line dash equals a list here. There's a couple of convenience things, like I think dash or dot dash or something, but you can also just give it a list of sizes here. Let's make that a little bit less alpha. So you can sort of control all the different visual properties of the line, and it's certainly fine to create multiple markers together. So if I wanted circles, if I wanted to create a line graph with some circles around it, that's perfectly fine. Circle, I can say something like fill equals white, and I can give it size equals 10. And sure enough, now I have sort of this line plot with the markers on top. And so these are going to be drawn in the order that you give them. So I gave the line first, it draws the line first, and the circles will be on top because it was added to the plot later, subsequently. Okay, so the next thing here, images, just to show this, I'm not going to go into too much detail about this, but there's a couple of different ways to display images. One of them is to use the image glyph method, where you give it a scalar array, an array of numbers, of values, and you give it a color map, and it's going to color map that in the browser, in the client, actually. But it's also possible to send raw RGBA values if you have raw RGBA values. So here I'm using actually NumPy to create this raw RGBA value array. I won't go into too much detail about that, but I call the image RGBA with this data, and I can get this nice image out. And again, so this has all the standard tools that you would expect, wheel zoom and reset and all of that. Just to mention other kinds of glyphs before we finish up this chapter, where to get more information, you can click these links. There's things like rectangles, ovals, segments, and rays. There are all kinds of wedges and annular wedges and arcs. Specialized curves, if you need to draw. People have done really interesting things with some Bezier and quadratic curves that are possible, that are parameterizable. And for instance, the chord chart that I mentioned earlier, someone implemented that using these Bezier glyphs. So there's all kinds of interesting things you can do. There's a few that are probably going to add fairly soon, a V-bar and an H-bar. So there's also quads and rects. And actually, if you want to draw a bar chart using Bokeh.plotting, it's sort of nice to have the combination of both of those. And so that'll be V-bar and H-bar. We'll probably add those pretty soon because they're fairly straightforward. But A lot of different kinds of glyphs in Bokeh.plotting. This is just sort of to get you started and get you pointed in the right direction. So let's take one more exercise here, and it's just really free form to plot some multiple glyphs together. Here we go ahead and show pretty much what I had before, right? We can plot multiple glyphs together. We have a line, we have a circle that's on top. So I'll give a few minutes before we take our break for y'all to create a plot sort of your own devising. This is a fairly open-ended exercise at the end here. And we'll sort of see what people come up with or questions that they have. So. Yeah, so there's actually a PR in flight right now. So one of the things about the notebook is that it's a little bit hard to work and debug in with the JavaScript. If the JavaScript is not loaded in time from CDN when you call a show, sometimes this situation can arrive. And there is actually a PR in flight that will be going into a 0.12.1 very soon that hopefully ameliorates this and prints out a nice big warning, and you can just retry things if that's the case. One thing you might try is to use inline resources as I described. Let me just go ahead and retype what I... Yeah, so unfortunately, the problem currently is that situation that you've gotten into left things in a fairly bad state. And so the PR leaves it in a much better state where you can just retry, re-execute the cells, and it should work if that has happened, that Bokeh.js is loaded too slowly. Or you can try inline resources next time, which again looks something like this from Bokeh resources imports inline. And then when you do your output notebook, you're going to do output notebook resources equals inline. So this, like I said, this used to be the default. We got a lot of requests to make CDN resources the default so that the actual notebooks that you can ship are smaller. They just have the link to the script to download. But you can certainly override that and use inline. It should work pretty much without error. I will say it's always good practice to put output notebook in a cell by itself at the top, right? Because it does take time to load the resources. We're using the Jupyter Notebooks cell publishing machinery to load this big JavaScript library into the browser. And so it needs time to do that. And so if you do it in the same cell as other things like calling show, that's when you especially might run into problems. So I always suggest to put output notebook at the top and give it a chance to sort of finish and make sure it's done. That's the best practice. The warning that actually happens in this PR that I've got now is very clear and explicit about, always put it near the top and put it, the best practice is to put it in a cell by itself. And so we always make a point to demonstrate that. So if you'll notice these tutorial notebooks, always have output notebook sort of in a cell by themselves. And that way you'll know that it's sort of succeeded. But again, we should have a 0.12.1 sort of bug fix release. 0.12 was a pretty big release for us. And so we're going to have a follow-on release probably, if not the end of this week, early next week. But we'll have a dev build before that. It's really easy to install our dev builds. We make it very easy to get our sort of development snapshot. So we'll publish that on the mailing list as well. Definitely encourage anyone to check out the mailing list. We have a lot of traffic on our mailing list now. Getting a bit hard to keep up, actually. But we try to answer a lot of questions, and other people are answering questions there as well. But we certainly announce things like dev builds on the mailing list, so please do check that out. Okay. Let's see. Right quick. Let's see what we can... Yeah, we'll talk... So there's a whole section on styling, layout, and interaction. So we'll talk about layout is what's covering sort of grids together. Yeah. Yeah, sure, I can talk about that a lot. So just for ease of presentation, we do most of the tutorial in the notebook. The short answer is that in addition to output notebook, there's something called output file, and you give it a file name, and that will just give you an HTML document. There's also ways to embed Bokeh in, for instance, if you're doing a Flask app. So if you want to, we won't go over it today, but there's the chapter, I think, 5 on embedding, and that'll show you the bokeh.embed.components function, as well as some other ways to embed. So just, like I said, for time, we don't have time to get to everything today, but that's where you can go. And there's a lot of ways to embed Bokeh documents. Yeah, good question. Yeah, question.
Can the output be a list?
Yes. Yeah, any of these visual properties can be a list. So if I want to go here, not for line because there's only one line, right? But for the markers in this case. Right, yeah. So in the case of line, there's only the one line. There is actually a multi-line glyph if you want to sort of draw a list of lists of lines. And you can specify an alpha for each line independently there. Yeah, line is a little bit of an oddball. Technically speaking, we could have done more of the VTK style, where we explicitly have geometry and then specify the topology separately, but has its own problems. Anyway, question. To auto-rotate the colors. So right now, there is I think an issue to add Cycler. Cycler is a nice library that was written by, I think, Thomas Caswell, one of the MPL devs, which does some nice color cycling. Right now, there's no auto-cycling in Bokeh.plotting. There's sort of Bokeh.charts does that, but it would be great. And if you have ideas about how you'd like to spell that, what kind of interface might be nice for doing that, please come by and let us and discuss it with us. It wouldn't be, I don't think, too hard to add. It's just a matter of, at this point for the library, we really want to be cautious and careful and add things that we're happy and content with and we know that we want to live. Because we are planning a Bokeh 1.0 release in the next couple of months. There's not much left to do in terms of being able to say these are the interfaces that we want to guarantee and support long term. So we're trying to be very cautious about that. But please start an issue and have a discussion about it. Yeah.
Is there a way to specify the color rather than keywords, like to use like a text or something?
So you can give the names, you can give the hex colors, yeah. Tuples might work. I think there's an ongoing issue possibly with tuples, but you can certainly give the hex values. In fact, that's, I can give one here. I can say something like color equals, 446688, and we'll get that out. That was pretty blue. Let's go back to, there we go. It's hard to tell.
So in order to add a second line to that chart, you just repeat the line?
Yeah, absolutely. Yeah, absolutely. Right, so we could do line width equals 4 here, and we would get a nice. So in this case, the data is the same, so the line's on top of the line I just drew. But you can add as many of these glyph functions as you want to a given figure. You just keep adding them, so it works. Yep, question. Sorry? Yeah, so that's another ongoing question, and I believe we finally have a path forward for that as well. So we just recently added a label annotation, and so we also recently made Bokeh extensible, so you can sort of add customizable pieces onto Bokeh without necessarily putting them in the core library, because the core library's gotten rather large, and we're actually trying to pare it down and split it up a bit. And to support LaTeX requires using a library like KaTeX or MathML, or MathTech rather, and those are really, really large. So we can't justify making everyone pay for LaTeX, the size of these huge sort of LaTeX JS libraries, if you only need it some people some of the time. And so I think we have a path forward on that. It's a fairly high priority. We can make labels that will support LaTeX annotations now. There are some interesting intersections here. Because the labels are going to be CSS, because that's what those libraries like KaTeX and MathTech use, it's probably the case that the LaTeX labels won't work very well with saving static images. And I'm just not sure there's much we can do about that, unfortunately. But we'll certainly do what we can. If people have ideas or expertise and want to come help out, please let us know. Okay, well, I think that sort of shows adding some additional markers there. And everyone's probably a little bit tired. It's a long tutorial. So let's go ahead and take a 10-minute break. I'll say 5 minutes so that we can start in 10 minutes, actually. And when we come back, we'll do another couple of chapters, and then we'll take a break again, and then Jim will take over for some of the other exciting topics. Welcome back, everyone. Hope everyone had a nice break. Tilt that down just a little bit. Let's go ahead and, well, I guess first let me see if there's any questions, just general questions before we get started. If not, we're going to dive into chapter 3, which is a little bit more information about sort of styling and visual appearance of things. Okay, so I mentioned earlier that at the lowest level, there's this sort of models API where there's these objects that can represent all kinds of things in your visualizations, things like the plot itself, or axes, or ranges, or or the glyphs that you're drawing, or the tools, or the toolbar. So there's all of these objects that we can put together, and some of the higher level APIs are meant for putting those building blocks together in meaningful ways. But at the bottom level, there's all the same building blocks, and so really this information, this styling, visual attributes can apply regardless of what API level we're working at. So again, we're going to start off with I'm going to demonstrate most of it though with the Bokeh.plotting API. So here we import, our standard imports. We do output notebook so we can see that it's successfully loaded. The first thing to note is there's just a wide variety of ways to specify colors. Again, we can use the name CSS colors. We can give RGB hex values. I believe there may be an issue with color tuples in some circumstances right now, but normally you can specify tuples as well. And then there are different sets of properties that things like glyphs can have, or things like your plot might have. So there's line properties. These are things like line alpha, line color, a dash, or a line width. There's some other more esoteric ones as well, like a line join or things like that. But these are probably the most common ones. Fill properties, not surprisingly, you can fill things with the color and specify the alpha for that fill, the transparency rather. And then text properties. So if you're drawing text, then you can specify things like the font or the style, the color, and the alpha there as well. So lots of things have these properties. As an example, we might have the outline of the plot, right? So we're drawing a plot, we have a sort of an outline border around that central area. Maybe we want to change the width of that. And so in this case, we would have something like myplot.outline line width, right? So sometimes these properties are prefixed with something like outline. All of these are documented completely in the reference guide, so you can certainly go to the reference guide. There's also a really nice user's guide that goes over pretty much a lot of these configurable options as well, in addition to this tutorial. So just trying to point everyone here at lots of different resources. But this is typically how you'd use it, something like, dot outline, line width equals 2, and that'll change that. So let's see some concrete examples. Okay, so we're going to go ahead and create a plot. So p equals figure. In this case, I also want to specify a plot width and a plot height. I can do that. And then I can say something like, I want the outline line width to be 7, so it's a really big, wide outline. I want the alpha to be 3. I want it to be navy. And then I can show my favorite sort of circles here. And sure enough, I get a really big, wide, transparent outline around my plot. Right, so hopefully that's fairly straightforward. Go ahead and take a look at some other plot level examples here. So I'll let y'all take a couple of minutes here and customize some of these things. And just as an example for some ideas, you might want to do, if you go to Bokeh, yeah, I should point everyone to docs anyway, bokeh.pydata.org, pydata.org. And you can either go to the user's guide or the reference guide, but if you go to the user's guide, there's a really big section here on styling visual attributes, and you can see a lot of different examples of styling, various different attributes here. There's typically live, code with a live generated plot alongside of it, and so you can maybe get some examples of the kinds of things you can change. But let's go ahead and, like here's, for instance, some title. If you want to change some of the title properties, you can do that. But I'll let y'all explore for just a couple of minutes and ask questions if you have any questions. And it'll be good. Give that. I guess I'm getting ahead of myself a little bit with this title, so I'll remove that. Yeah, absolutely. All of these should autocomplete in the notebook, right? So I have a plot up there, so I can just hit P-tab and I can see, there's quite a bit of stuff here. So there's all of the glyph functions that we saw, like circle or arc or annular wedge, but there's also, you can see background fill, background alpha, border fill color, border alpha. So there's not a really good way for us to pare that down from things that may not necessarily always be terribly interesting to you, but definitely a lot of, all of those should be here. So you can tap complete, or again, as I mentioned, the reference is also auto-generated. It's 100% complete. We have a lot of automation around our documentation. So if you go to the reference here and you go to bokeh.model, and in this case it would be models, and then you go to plots, and we look at a plot, we can sort of see all of the different figures. Here's border fill alpha and background fill, and you can see all the stuff here. And so yeah, so those are different ways you can find out, is either the documentation or the tab completion. Yeah.
If you don't specify background color, is it transparent?
No, I believe it's white by default.
Is there a way to
Yeah, absolutely. I mean, you can specify. So one thing we won't get into this tutorial is there is a way to sort of apply some themes. But just in general, the themes are just setting property values. And so in this case, you could set the property value for the background fill alpha to be 0. And that should allow it to be transparent. We definitely make use of that. So for instance, there's a GMap plot that we do, which lets you have sort of a Google map behind some bokeh visualizations. And the way we do that is by having a transparent canvas, and then we can render glyphs on top of that. So yeah, that's definitely possible. It just isn't the default. Yeah.
So the other question is, can you save figures?
So again, you can save these as an HTML plus JavaScript document. And
Save like a page?
there is a save tool that you can add, but it requires currently human intervention, right? So here, if I go up to the top, I can see this save tool. I can click on the little save tool, and that's going to give me this image here that I could, right-click on and download. Or some browsers that supported that will actually open up a download dialog automatically. In terms of programmatically generating static images, that's an issue we're hopefully. I've said that before, but I do believe we're hopefully on a path towards that. Sarah Bird found a really nice SVG library that seems like it might actually work for us to convert canvas commands into SVGs. So we're going to try to leverage that to get out SVGs programmatically. But like I said, it's kind of a thorny problem. Being sort of cross-language, cross-runtime, browser security restrictions, it just makes it a very thorny proposition. And one alternative would be to write an entirely other backend, and that may eventually someday be what we do. Matplotlib is planning a JSON serialization input-output format, and if that comes to pass, then we could maybe use Matplotlib as a backend for rendering static images, because there's a lot of work that's gone into that, but that hasn't come to pass yet. So, okay, good questions. Yep. Sorry, I missed the first. No, so I said it's possible to define a theme, and when we get to the Bokeh apps, I'll show how to define like a theme file. And there is some basic theming. Actually, one of the upcoming bits of work we're actually probably getting funded to do is to make it even simpler and more easy to specify themes. So there's some basic theming functionality, and we'll get to it when we get to apps at the end of today. Okay, good questions. All right, so we've talked about styling sort of basic plot stuff, but it's also possible to style all of these glyphs. The glyphs have properties as well, right? So we've seen how we can give the circle a line color or a fill alpha. So maybe we can also step back and sort of show things at a little bit of a lower level here. You can actually get back, when you call p.circle, you can get back what's called a glyph renderer, and then you can find the glyph for it, and you can set all of those properties that you set when you call p.circle, but you can set them explicitly here if you want to, or you can change them later. Right, so here I'm getting my glyph, and I'm setting the size and the fill alpha and the line color, and if I execute this code, sure enough, I'm going to get my plot here that has sort of the fire brick, with the dashing and the line width around it and the alpha in the center. So again, just to mention here, when you call something like p.circle on a figure, you get back what's called a glyph renderer, and the glyph is what you can set those properties on. The reason there's r.glyph is because there's actually other things. There's things besides just the regular glyph. There's something called the selection glyph and the non-selection glyph. And these are really for being able to specify if you want to do a selection, like with a lasso tool or a box tool, and you want to control, what do the things look like when they're selected or when they're not selected. That's what they allow you to control. And so let's take a look at it, and then I'll let everyone have a little bit more time to sort of read over this section and ask questions. But here I'm calling circle, and I'm passing in this case, I'm just passing it into the glyph renderer, because that's fine too. Non-selection fill alpha, non-selection fill color, things like that. The selection color is firebrick. And so if I show this plot, and now I've got my tap tool, which lets me select things by tapping on them, then sure enough, right? The unselected ones look one way because I've given some properties for non-selection glyphs and what they should look like. And the selected one looks a different way because I've also specified what the selection should look like. So you can either do that as I've done here by providing the keyword arguments to circle, or up above, you can also do r.selection glyph equals some glyph, or r.non-selection glyph equals some glyph. And so this is probably the easiest way. If you're using Bokeh.plotting, this way inside the code here is probably the simplest way, and that's typically the way that I do things. But for completeness, there's a little bit more lower level information here. So let's maybe make, actually, sorry, not quite yet. One more demonstration before the exercise. In addition to selection glyph and non-selection glyph, this is actually kind of nice. There's a hover policy. So if you want to set the policy on what things should look like if they're hovered over, there is also a hover fill color here. So I can specify the hover fill color or the hover alpha or anything like that. And so in this case, I've created a line, I've created a circle, I've added this hover tool, and we'll talk about hover tools a little bit later. But in this case, I've specified the hover to be, the hit testing to be a line, horizontal wherever the cursor is. And so as soon as that line intersects the glyphs, the hover policy is applied. And so you can see that the hover policy I've specified is for the fill color to be this red color and to have this alpha. And so you can see that automatically updates. So I didn't have to do anything special. I didn't have to write any code to make that happen. I can just specify the policy that I want for my hover policy, and it's very easy to do. So, okay. So I think, again, another exercise here is a little bit open-ended, but I would suggest taking the set of code up here that has the non-selection and selection glyphs, and starting from that, and just tweaking and changing those parameters and sort of seeing if they respond and how they respond according to your expectations. And if you have any questions or problems, just let us know. I think for this one, we'll take a few more minutes, maybe 3 or 4 or 5 minutes, and let people really, one, read the expository text around it, but also have a chance to ask questions and play around. If you're feeling of interest, definitely, you can sort of take this code as well and tweak it and change some of the hover, the hover fill policy or the hover alpha, the hover line color, excuse me. You could also see what happens if you change this to V-line, for instance. Whoop, didn't like that.
The glyph colors, the glyph properties,
Yeah.
can those be lists as well?
So they can be, oh, yeah, I see what you're asking. Let's see. So the question was, can the hover policies be,
Glyph policies.
yeah, sorry, the glyph policies like selection or non-selection or hover, right? The standard glyphs, absolutely. For the
Actually, I meant more where you were using colors that, in the, glyph fills
ye-
and outline colors.
yeah, absolutely. Like this right here, you absolutely can give a list of colors here, yes. Sorry. And I believe that's true also for the policies, although I don't think that's been demonstrated very often. But you can certainly, yeah. So the colors, all of that can be, and maybe a good example of that to show, let me go to the docs here. If I go to the gallery, we do have a nice gallery as well. That's a good place to sort of get started. One of the things about a really highly compositional system like Bokeh is that it's possible to put together things in a wide variety of ways. And so at least for me, the easiest way to learn is to sort of learn by example. Here's this color scatter, and you can see exactly that. We've constructed a list of colors here. And that's what we've passed as the fill color. It's this, obviously the font there is really tiny. So we create a list of colors, hex strings, and then we pass it to the fill color equals colors, and that gives us this, this thing there as well. That, by the way, was there's also possible to control the level of detail. So if you want to maintain high interactivity, it's possible to have Bokeh automatically basically sort of subsample the data during interactive events, and so that allows you to have really responsive pans and zooms and things like that. So, okay. Well, like I said, give everyone just a few minutes to play around with that. Let me go ahead and restart. I see that I've gotten into that state that I mentioned earlier. So again, I'll have a dev build out very soon that should sort of rectify some of these race conditions that can happen in the notebook, make them a little bit better, and I'll try to actually have a dev build out maybe tomorrow morning. In the meantime, I will restart my notebook. Okay. Questions or comments about some of those glyph selection policies? There's definitely more examples in our examples directory in the GitHub repo. We can see sort of lots of examples there. But yeah,
Yeah, can you expand or contract the range that the hover lights up?
I'm not quite sure I follow.
So like the hover, like it shows you all the points on the side. That's more than like an exact match at that point, right?
Like here, so I've changed it to V-line, by the way, but you're asking. Oh, well, so there's 8 points that intersect the line that's vertically from the, so there's, the circles are overlapping quite a bit, right? So it's whatever circles happen to intersect the vertical line. If we were to zoom in, I didn't add a zoom tool to this, but if we were to zoom in, you could get to a point where you would see just one circle, but the circles here are very close. So I mean, maybe if I make the alpha a little bit less, we can see that a bit more clearly.
Okay, so even though they're crawling up and down that line, they're saying that there's that many points at that exact spot?
Well, sorry. Yeah, maybe I will draw something on the whiteboard. Sorry, I'm actually running into that issue quite a bit all of a sudden, but yeah.
If they were tiny circles, only one would overlap the line.
Yeah, so let me,
Because the circles are big, lots of them overlap the line.
yeah, so let me maybe draw a quick picture on the whiteboard. So with this mode, so here we have a lot of circles that are overlapping quite a bit, and that's why the alpha is so low, is because they overlap quite a bit. And with V-line, if your cursor is here, it's saying I want to hover over every single circle that intersects the line extending vertically up and down from the cursor point. Well, that's 3 circles, this circle, this circle, and this circle all intersect that line, right? There's not a single circle that, so there's also a point hover mode where you would intersect over every circle that's, underneath, just directly underneath the mouse. And H-line is sort of a horizontal rule. But any circle that, so if you zoomed way in, and you only got to a point where you were hovering just above this one circle, then just that one circle would light up. But right now, the hit testing is hitting more than one circle.
Okay, and because the size of every circle is 20, that makes for a lot of them on this.
Yeah, that's why they overlap a lot. So if you made the circle size quite a bit smaller, then that would also probably get you just sort of highlighting one circle at a time. But it's whatever intersects that line, right? Which in this case is more than one circle at a time because the circles are so big and they overlap. Yeah. Okay, so I'm, for some reason, in this notebook running into that issue quite a bit. Let me restart one more time and then we'll move on to axes. Great. There we go. Okay, so we are on chapter 3, styling visual attributes. I'm going to get through this fairly quickly. There's a few more words I want to say, but I think we can get through this fairly quickly. So some of the things we might want to style are things like axes. So let me go down to the axes section here. The first thing to mention, this is actually maybe the really useful thing, is that obviously a plot can have more than one axis, or more than one x-axis even. And so we have these nice accessor properties, things like p.x-axis or p.axis, and they return a list of axes, right, to be clear, right, because there may be more than one x-axis. You might have one at the top, one at the bottom. We might have multiple axes on either side. So this returns all of the x-axes, however many there are. But as a convenience, because you often want to change the properties on them, and because there often is only one, it's possible to set attributes on this return list. So it's sort of a special kind of a list. We call it a splattable list, some terminology we made up. So even though p.x-axis returns a list, I can say something like p.x-axis.axis label equals temperature, and p.axis.major label text color, so the color of the labels, and set that. And that will set every x-axis, however many there are. So it's just a convenience. Sometimes sometimes it's more of a confusion than a convenience, I guess. But let's go ahead and take a look at some things. So if I create a figure here, see if I've done my imports, then now we can do p.x-axis. And we can also tab complete on that, right? So we can see all the different properties that can be changed, right? So I can say p.x-axis.axis label to give the label an axis. I can change the text color, right, or the text font. I can change all of those sort of properties. And again, the tab completion in the IPython notebook is a nice way to sort of see what those different properties are. Do that again. There we go. So you can change the dashing on the axis. You can change the ticking. How far does the tick, how far does the tick extend inside the plot? How far does the tick extend outside the plot? Here's a list of all the different axis properties, right? So an axis itself has line properties. The label has text properties, as well as a standoff that controls how far it goes. The major label is the labels for each of the major ticks, right? So if I go up to a plot up here, these are the major labels, right? There are major ticks, and there are minor ticks in between, but the labels are on the major ticks, so we can control the font or the font size or anything like that for those major labels. We can also control the line properties of the major ticks and how far inside or outside the plot they extend, or same thing for the minor ticks as well. So let's take a look at maybe a concrete example. Here we go. So again, I'm creating a figure. I'm drawing these little X markers, and now I'm saying I want the orientation of the major labels to be pi over 4, and I want the y-axis orientation to be vertical. And if I show this plot, then sure enough, we can see that now the x-axis ticks are rotated at 45 degrees, and we can see the y-axis ticks are now at this vertical orientation, right? So we can control all of those things. The next example here sort of shows a lot more, right? So we can change the label on the x-axis to be temperature, and the line width to be 3, and the color to be red, and the same thing on the y-axis, we can change it to be pressure, and we can change the text color and the text orientation, and we can also control how far the ticks extend in or out. So in this case, tick in equals -3 means that we actually want to start outside the plot. So we actually get ticks that are only outside the plot in this case, right? So you can look here and see that the minor ticks start at sort of -3 inside the plot, which is the same as 3 outside the plot, and then extend to 6 outside the plot. Things like coloring labels is actually going to be very nice if you have if you have a multi-axis chart, like if you maybe have multiple y-axes. It's very often nice to either change the color of the axis label or the axis tick marks or something like that to correspond maybe to a particular line or a particular set of markers inside the plot, right? And it's a nice visual cue that these markers correspond to this axis and these markers correspond to some other axis. So that's often very nice. Okay, so I will take a few minutes here and let everyone go ahead and customize an axis or two. Again, I would suggest just starting with the code that's here and tweaking it and seeing how it meets or doesn't meet your expectation, and then ask questions based on that.
Did I understand that if you've got a fully rendered notebook and you render it with NB Convert, you won't get the figures?
NB Convert has all of the JavaScript inside, and so if you execute the notebook and you render it, it has all the JavaScript ready to go. Whether or not the figure shows up depends on where you're looking at them. If you're looking at them locally, it's great. If you're looking at them on NB Viewer, that's great. If you're looking at them on GitHub, for instance, they're not going to show up because.
If I do the subsequent conversions into LaTeX and PDF,
No, probably not. Yeah, probably not. I don't.
it's easy to get a printed version.
Yeah, no, not right now. So these are definitely, I mean, our interest in creating Bokeh was for interactive visualizations in the browser, and so that's, I'll make no bones about it. That's the use case that it serves primarily. We absolutely want to get to a point where we can try to have better support for static images and static output, and I know especially in this context that's very important, but again, that's sort of a tricky technical problem that we're still grasping with. But I do hope that we should have SVG support before the planned 1.0. I think we have, like I said, I think we have a fairly clear path forward at this point. We had a nice prototype PR that actually worked to some degree, so it's a matter of sort of going back and finding that polish to make that PR work at a really acceptable level. But yeah, thanks for asking. Okay, so I'll just change a few things here. So in this case, I'll change this to 3, and now maybe we want to have the ticks extending all the way inside. And so now the ticks are inside. Again, a negative tick in or tick out value just means to sort of, go the opposite direction. Okay, so in the interest of time, I'm going to go ahead and go through the last section here on grids. I'm just going to show some examples, and I don't think we will, the exercises are pretty much the same, so I think we'll sort of skip that, and same thing for legends. So here for grids, they're the same kind of thing. We have these nice accessors, p.xgrid, p.ygrid. P.grid will return all of the different grids, which is the lines here that crisscross here in the center, and you can control, again, all the properties of that. You can control, how transparent they are, what colors they are, what the line dashing is, whether or not there are filled bands in between them, and so let's take a look at some of that. There's p.grid here, and so there's grid line color. If we want to get rid of our x grid, and we can set like the line alpha and line dashing of the y grid, and if we show that, sure enough, it's very hard to see here. Let's maybe make it not quite as transparent. Kind of shows up barely, but anyway, you can see that there's no grid that intersects the x-axis because we set the x grid color to none, and the y grid here, which intersects the y-axis, is dashed and is very transparent. So depending on what kind of chart you're doing, that might be much more appropriate if you're really trying to show, for instance, the height of bars, and you don't need the other grid. Same thing for bands. There's also, on the grids, there's a band set of properties. So there's band fill alpha and band fill color. And so in this case, if I set, band fill alpha to 0, 1 and band fill color to navy, we can see we have this nice set of bands in between the grids. So again, all of those are the same kinds of properties. Basically, there's always text properties, fill properties, and line properties. And just they show up all over Bokeh. So once you become familiar with those, that information, that knowledge is very repeatable and very useful all over Bokeh. And again, last example here is just about legends. Let me go ahead and show. So there's a low-level way of creating legends, but with Bokeh.plotting, there's a fairly easy way to create legends at a high level, and that's simply by adding a legend keyword to your glyph methods. So here I've called p.line, and I've given it some text as a legend. I've created a circle and a line, and I've given it both of those the same different legend string value. And Bokeh simply collects all of the similar legend values and draws those in a legend at the top, right? So here, in this particular case, let me make this a bit smaller. We can see I put the legend at the bottom, and we can see that the first two that had the sin x legend are collected here. The middle one that had the line is collected here, and the other one that had the markers collected here. So as a Bokeh 012, it's also possible to put legends outside. It's a little bit maybe clunky right now to add a layout outside, but there's an example in the user's guide of adding a legend outside the plot. And we'll be making that even easier in follow-on releases, but there is an example in the user's guide. Let's go ahead and go there, just in case you're curious. Bokeh.pydata.org, we go to our user's guide, and I believe, plotting under basic glyphs, and there's legends under adding annotations. And so you can see you can control lots of things about the legends, their position. Let's see, actually this is not the section I wanted. Oh, yeah, it's styling visual attributes, there we go. So if we go down here, there's a lot of examples of styling all kinds of visual attributes, more than we have even in the tutorial. And so we can see, for instance, the location here. So there's, inside the plot, but we can also have now legends outside the main plot area as well. So you can sort of see a code example of how to do that. Excuse me. You can also orient the legend horizontally. In this case, we've instead of stacked them vertically. You can change the things like the font to the legend and the outline. So all of those things are, again, controllable by the same kinds of text, line, and fill properties that show up all throughout Bokeh. Okay, well, let me go ahead and go a bit through chapter 4, and then we'll take a break. And then James is going to take over and show us a bit about GIS and data shader and HoloView's integration with Bokeh. So go ahead and close chapter 3. Any questions before starting chapter 4? Okay. Yes?
So on this one, you have the legend command in both the line and the square.
Yeah, oh, sorry.
If you take that out.
Yeah, let me load that back up. So what, yeah, so this is actually good. I'll have to re-execute this, sorry. So what Bokeh does in this Bokeh.plotting sort of way of adding legends, which is a little bit, made a little bit simplified for you, is that it collects all the legends that are the same, right? So the circle and the line together both say sin x, so when it draws a sin x legend, it draws that circle and that line. So this is just a way to tell which one should be grouped together. So the middle one there just has 2 times sin x, and it's just the line, and so when it draws the 2 times sin x legend, it just draws the line. The last one there is 3 times sin x, and it has both the line and the square, and so it, again, Bokeh automatically collects all the legends for that, for that legend name, and draws representations of them in the legend, so the line and the square as well. Yes?
How can you change the number of ticks that you put on each axis? Like, you just want even or just
Yeah, so the question is how to change the number of ticks. So there's actually different, so at the lowest level, ticking and the appearance of ticks is controlled by what's called a ticker and a tick formatter. And there are various built-in models for having different kinds of basically policies for ticking. Maybe you want to tick at a fixed interval, or maybe you want to have a date time ticker that can generate ticks across different scales. Maybe you want to have whatever you want. So some of those have configurable, tunable parameters in terms of maybe the number of ticks you want, but other ones, I will say the other thing you can do is it's actually now very easy to extend Bokeh. You can actually write your own custom ticker and custom tick formatter very easily, which is a little bit beyond the scope maybe of this tutorial, but if you come to the mailing list, we'll happily point you in the right direction. And that gives you complete control over where and how many ticks you draw. I think actually in the last, in 012, we just added a function tick formatter that lets you give a little bit of code that actually will let you just write a function to do tick formatting. I don't think we have a function ticker quite yet, but we could add one pretty easily, which is probably a good idea. So there's a lot of flexibility there, and it depends. So there's a basic ticker that just sort of tries to pick nice numbers across a wide scale. But if you want to dive down into it, you might want to look at different tickers or even a custom ticker. So, good question. Yeah. Oh.
In one of the earlier notebooks, you had the legend from a data frame automatically the name of the
Yep.
other column basically makes the legend. If you wanted to put that legend outside, I don't see it.
I don't think there's any support for that now in Bokeh.charts yet. That's a great feature, and I would love to do it. I don't think it's right now. So the question was about Bokeh.charts legend. So Bokeh.charts, again, automatically generates a legend for you, right? So, but currently that legend's inside. And you can control the legend position inside using top left or center or bottom right. But there's no provision right now for putting a Bokeh.charts legend outside, and so that would be a great feature to add. And I don't think too much work, but it just hasn't been done yet. So, okay. Other question? No, but that's also a feature that's on our list. And in fact, that almost made the cut into 0.12. 0.12, as I mentioned, was sort of a fairly large release for us, and it had gotten sort of a little bit longer than our normal release cycle. So rather than delay it longer, we went ahead and had the release. But an interactive legend lets you basically toggle on and off glyphs by clicking on it, is absolutely on the roadmap, and some preliminary work, and I think a PR that may be currently closed, but we're going to reopen, has already been done for that. So that'll be in a 1.0 feature as well. The question is, how many people do we have working on Bokeh full time? That's a really rotating cast. It really depends. So, there's been work or there's been support for Bokeh coming from various different directions. Several years ago, we were applied for and received some money through the DARPA X Data program. It's a mandate to develop open source tools for data science, and so Bokeh is one of the projects that received funding through that, and so that actually helped accelerate the development. Continuing, we also have client engagements that help support Bokeh, and so people either want specific features or they want to integrate Bokeh into what they're doing, and some of that work helps drive new development in the open source tool as well, and we're always happy to engage people in that way. But in terms of right now, so it's gone up and down. Towards the end of last year, when we sort of had a second generation of the Bokeh server, trying to take all the lessons that we learned from the first one that sort of didn't work so well, there was a lot of people working at once. But right now, it's a much smaller group, and I would say, maybe there's sort of 2.5 people's time total, but that sort of rotates again in and out between different people. So it just depends. Oh, well, thank you. But again, that number's gone up and down. And I should also say we're getting a lot more outside contributions. So I think we just passed 170 contributors on GitHub. I try to be very extremely welcoming, and I try to always take as much time as necessary to help anyone that wants to come and get involved in Bokeh development. A lot of those contributions are really, fairly small, but I appreciate every contribution regardless of how small. But also a lot more substantial contributions lately as well. And so I'm happy to help anyone get started in Bokeh development. One of the reasons we also made Bokeh extensible is so that people don't have to wait on us, right? Now you can basically customize and add custom behavior, wrap new JavaScript libraries and connect them to Bokeh and to Python without having to wait on us, right? Or without having to get too deeply involved into development. I want to lower that bar. So if you're interested in development, please please come talk to us. We'd love to get anyone making PRs or working on things and making demonstrations, whatever. So anyway, thank you. Good question. Okay, so let's go ahead and again, sort of speed through. I only have about 15 minutes here. Speed through chapter 4. We might take a little bit longer. So this chapter is about layouts, widgets, and interactions, right? So let's sort of take a step back and sort of see what we might want to do. So again, standard imports here, bokeh.io import show. We call output notebook because we want to see things in the notebook. The first kind of thing we might want to do is a grid plot. So if we look at bokeh.layouts as the new module, this is too small of a font. Bokeh.layouts, import grid plot. We can create several plots now. So in this cell, I've created, S1, S2, S3. These are different figures. One of them has a circle, one of them has a triangle, one of them has a square. And then I can call grid plot, and I can just give it sort of this nested list of plots that we want to do. In this case, I don't want a toolbar, so I can also say something like toolbar location equals none, and then I call show, and sure enough, I get this. And so if we wanted a different layout, maybe we wanted to have vertical plots. So grid plot again takes this sort of nested list syntax here. That would give us a vertical orientation. And there's a couple of different ways. We'll see in a minute. There's also a row and a column. If you've been using Bokeh before, you might notice that there used to be things called hplot or vplot or hbox or vbox. It was kind of confusing. Those still exist, but going forward, the new models at the lowest level are things called row and column. We did a lot of work on layout 0.12 in terms of being able to auto sort of line different plots up and in a nice way, especially in some of the Bokeh apps situations. So those are the new things, and that's what we're going to demonstrate here and also in the documentation, but all the old code should still work as well. But just to mention that. Okay, so next exercise here is just to create a grid plot of your own. I've already sort of changed this here, but you might try some different combinations for creating a grid plot. Again, I would just start with the code that's here and sort of see what happens if you try different things. Yep, question?
Can you not plot the same thing twice?
Yes, the question is, can you plot the same plot twice? I believe right now that doesn't work very well, right? Because the reason is that, there's specific, like a lot of, so that, it's a sort of a cross-language situation we have here. We have a set of classes and models and objects in Python, and we sort of mirror those into JavaScript. And so when we do that, there's a particular ID attached to any Python object so that we can identify it with the JavaScript object. And so if you plot it twice, you sort of have two of them, and that doesn't work very well with some of the machinery. And so there may be, I think there's an issue to discuss this, and we may want to do some things about that, or it may just be something that we need to try to warn about better when it arises. But yeah, right now I think that there's an issue with plotting the same plot twice in the same layout. Good question, thank you. So there's grid plot, there's row, there's column, and there's also a very flexible what's called the layout function. What's that? Yeah, absolutely. Yeah. So if we go up here, let me go ahead and turn this back to the way it was so that it's horizontal, takes up a little bit less vertical space. So here I've given it this nested list, and there we go. So, but there is a row and a column, and we'll see row and a column in just the next exercise after this one. I'll go ahead and scroll down to the one that I created for my exercise here, where I just gave it sort of a nested list in this way. Yeah. So you want to create two plots times 2? So in this case, you can, I don't have a second plot here, but let's create a new plot, S4. We could just do S3 times S4, right? And we would get 2 by 2. So basically, it's the outer one is going to be the number of rows, and then the second one is going to be each. And I have that backwards. Yeah. I always get confused. So the outer one is actually like the column, and then each one is a list of rows, right? So there's a nested list here with one element in it. So there's one row, and in that row there's 3 elements. Here I have a nested list where there's 2 elements. So there's going to be 2 rows, and each element has 2 things in each row, S3 and S4. So there's also, again, we'll see in a second, there's also just row and column. If you just need a row and a column, you can sort of nest those arbitrarily, which might be clear, or if that makes more sense, then by all means you can nest rows and columns explicitly. Grid plot just tries to use this, I think, fairly standard nested syntax that other libraries use as well. Okay, so this is the one that I did. So again, I created 4 plots here. I have a grid plot where I passed a list, and the outer list has 2 elements. So there's 2 rows of plots, and then the inner, each of these has 2 things in it. So there's 2 things in this row, and then 2 things in this row. I can say something like, let's see if this works. Right, so it's possible to do, one thing that grid plot does that's worth mentioning is grid plot by default coalesces all of the tools or gathers all the tools together. There was just a recent PR to turn this off if you don't want it, and certainly with nested rows and columns this doesn't happen automatically, but with grid plot it tries to say, hey, I don't want to draw 4 toolbars, I'm just going to give you 1 toolbar, and so if I select the wheel zoom here, they all have the wheel zoom active, right? And if I select, the pan tool, then now they all have the pan tool active as well, right? So it just tries to make sure that you only have 1 toolbar that covers all of the different plots. But you can turn that off in the next dev build or the next release. We'll have a flag, turn that off if you want, because not everyone wants that. Okay. last thing here, let's go ahead and take a minute or two and show columns. So there's bokeh.layouts.row, bokeh.layouts.column. Maybe I'll just actually do this as a demonstration. You can ask some questions if you have any questions, since we're a little pressed for time. So here I'm going to go ahead and take all of these S1 through S4, and I'm going to import column here instead of grid plot. So, and now I can actually just give it a list of plots if I want to. I think it takes the nested syntax, or the list syntax too, but I can also just give it a list, column S1 through S4, and now I get a column of plots, right? So there's a row, there's a column, but these don't automatically coalesce the toolbars, right? So this, every plot here has its own toolbar, so I can activate the pan tool here, but differently activate, the box zoom tool here. So just to be aware of that distinction. Okay. The reason we wanted to set that up is because, oh, question.
In the grid plot, can you make one plot span columns?
I think right now you would need to do nested rows and columns, where if you had like, if you had a column that had a row that had two things, and then the next column had, or the next row had one thing in it, then you would automatically get this nice lined up. But grid plot, I think it tries to make things in a grid and just leaves empty spaces if you trail off on the end. I could be wrong about that, because this is fairly new, but yeah, absolutely. So let's try to do that right quick with the row and column. Where do we go here at the bottom? Let's just try something. So let's import column and row, and now what we want to do is do a row. S1, S2, S3. Oh, I don't know why my notebook is jumping around. S1, S2, S3, and then S4. And, oh, sorry, there's a sizing mode. So a lot of this layout stuff is very new, and I'm not the person who wrote it, so I may be not the best person to ask here, but let's see scale, width. And there we go. So my screen here is very small, so this is showing up a little bit weird, but what this does, and I notice there's a visual artifact here, so let's make this a bit bigger. Yeah. So what this does is to set that to be, but we need to set it on the row as well. So here if we go, on the row, and set the sizing mode there. Cannot type. There we go. So now we get this sort of nice responsive layout where they all sort of span. I will say there's a lot of really new cool stuff in the layout work. It's also very new, and so part of the reason for the 12.1 release coming on and the 12.2 follow-on is to smooth over. Again, it was sort of a bigger release than we normally have, and so I'm sure there are kinks to sort of make easier or to even to fix up. But we have some fantastic people that are working on this, and so I look forward to some really good stuff there. But yeah, but this gives you this sort of sizing mode. There are some examples of this under examples how to. There's examples how to layout, and there's actually some nice documents and notebooks there that describe the different sizing modes you can use and show how to have much more complicated sort of layouts. So I would direct you to that. Okay, so let's see. Running short on time. One of the reasons we wanted to get to layouts is to be able to show things like linked interaction. So one of the things that's really nice is in Bokeh, if you want to have some of the linked interactions, it's super simple to do. Like if you want to have linked panning between plots or linked selections between plots that share the same data source, super easy. So here in this case, let me make my font bigger. Here in this case, I've created 3 plots. Now notice what I've done is in the S2 figure and in the S3 figure, I've said things like X range equals the X range from S1, or in S2, I've actually given the X and the Y range from S1. And so what happens when I do that? When I share ranges between plots, what happens? Well, it's very simple. Now the ranges for the plots are shared. So if I pan one, the second plot there shares both ranges with the first plot. But the third plot, you'll notice, it only shares the X range. So it doesn't move up and down, but it does move left and right. So it's really easy to have this kind of linked behavior. You don't have to write any code to do it. If you want linked ranges, you just share the ranges between 2 plots, and that automatically happens. So again, I think for time, we're going to go through just some examples here, and please stop me if you have questions. Linked brushing is very similar. And actually here we might want to take some time for an exercise, because I want to introduce something new here, which is the actual underlying sort of data structure that drives all of these glyphs is something called a column data source. And I think we haven't done a good job maybe of sort of surfacing what that is or advertising it. It's actually a fairly simple concept. It's a dictionary that maps names to columns of data. It's very sort of like a cheap version of a pandas data frame, right? It's just a dictionary that has string names and they're mapped to columns of data. There's an assumption that the columns really should always all be the same length for every column. So when you pass in actual data like a Python list or a NumPy list to Circle or whatever, underneath the covers it creates one of these column data sources for you. But it's possible to create them by hand. And the reason that can be nice is because you might want to share a column data source between two different figures. So look, in this case, I create some data x, y0, y1 with, with NumPy here, or actually I just use list comprehensions, and I create some lists of data. Now I create this column data source, and so I say, what is it? It's a dictionary that has, the x values as the x key, the y0 values as the y0 key, the y1 values as the y1 key. And now when I call circle, I don't give it the actual data, right? I say that I want the x values to be this x column and the y values to be this y0 column. So I give a name for the column. Similarly, for the second circle there, I say I want the x values to be the x column, but I want the y values to be the y1 column. So y0 is this absolute value of x, and y1 is this x squared. And you can see that sure enough, the first plot here on the left is absolute value of x, and this is x squared. But what happens because I've shared the data source between them is that if I make a selection on one plot, that selection is mirrored automatically on the other plot. So again, I don't have to do anything to make that happen. It automatically makes that selection happen because I've shared the data source. This weird lasso tool size there. Anyway, so that's a nice sort of feature, is that you can get all these kinds of basic linked interactions just by sharing ranges, just by sharing data sources between plots. And you can do quite a few more sophisticated things that people have done with some things called custom JS callbacks that we'll talk about here in a second. But I mean, if you have the same sort of data frame between two plots, it's really easy to get this sort of behavior.
Column data source be a pandas data frame?
You can create a column data source from a pandas data frame. There's a from df function. Yeah. So there, again, if people have suggestions, we love having discussions. But there is an easy way to create them from pandas data frames. We've thought about maybe trying to do an automatic adaptation from pandas data frames. The main thing is we just didn't want pandas to be a dependency of the sort of the core library. It's unavoidable for charts, but for the core library, we tried to be as lightweight as possible. I think that a dependency list for Bokeh is down to like 6 or 7 things now. It's pretty small. Oh, sorry. Yes, well, you can. So you can get the selection both in a custom JS callback, which is a callback that's written or compiled to JavaScript that runs in the browser, and you can also get the selection in a Bokeh server app, as we'll see, right? So as an example of getting the selection, maybe I'll go to, again, back to this site, demo.bokehplots.com. This is this linked selection histogram. So this example here has a nice scatter plot in the center. Yay, conference Wi-Fi. Here we go. Has a nice scatter plot in the center, and then along each of these axes, we have some plots that show the histogram, the distribution of the data along the different directions. If I make the selection here with this box selection tool, then what happens is it draws both the histogram of the selected points in dark blue, and I don't know if you can see it down below, there's a histogram of the unselected points as well added to that, and same thing on the other axes. So that's because that selection is available and can be used to compute those new histograms. Okay, good question, thank you. Okay, so again, speeding along, I don't want to take up too much time here. The hover tool is another important tool to demonstrate. It's another reason you'd want to have control over the column data source at a fairly low level, is because you want to be able to know exactly you want to be able to add extra columns, right? So above, when we created our column data source, we added X, Y0, and Y1 columns, and that's all, all of those were used to draw things. But we can add any extra data we want, right? So here I might create a column data source that has X points, Y points, and then this description column. And we're not actually going to use that to draw anything, but what we can do is we can configure our hover tooltip to show that description column whenever the point is hovered over. So let's go ahead and run all of this. And now if I mouse over the dot, that's interesting. I got a little bit of a weird CSS issue there. I'll have to look into that. But you can see the description is showing up. I've hovered over that fourth point, and so I get the description for that fourth point. The corresponding description for the fourth point is E, or this one here, the corresponding description is D. It's also possible to have a custom hover, so you can customize. In this case, we actually have URLs that we've associated, and you can load those URLs in the hover tooltip. What I'm going to try to do really soon is actually embed a Bokeh plot in one of these hover tooltips. I'm not sure that there's any reason you couldn't, but I've never tried it, and someone asked recently, so I promised I would take a look at it. But you can certainly customize the appearance of the tooltip. It's basically like a sort of Jinja-style template. The basic default tooltip, though, you configure it with a list of tuples where the first element of the tuple is the name of, here I'm showing index, X and Y position, and description. So you can see index, X, Y, and description are the labels for my tooltip. And then there's a couple of special variables here. All of this is described in the user guide. $index gives the, if this is the third data point, that'll show 3. If it's the fourth data point, it'll show 4. $X, $Y show the actual X data, X and Y positions. And then the @ symbol here, we can refer to any column in the data source with this @ symbol. So I use @description, and that gives me whatever the corresponding, if I'm over the third point, that'll give me C, right? Or if I'm over this point, it'll give me D. So it tells me look into that column and show this in my hover tool. And so you're able to get that sort of drill down by specifying that. Okay.
On the custom thing, I don't see where you're.
Yeah. If you actually clone the repo, there is a utils.py corresponding, and it's in there. But if we can go to the user's guide.
So it's not in the data that you're using here.
Uh,
You're actually specifying it in that other spot.
Yes. So I think what it does, I'd have to go look because I actually don't remember. I didn't create that example.
I'll take your word for it.
Yeah, but I do want to show right quick.
No, I didn't see it.
Yeah. No, I think there's an extra column that has basically a list of URLs for every. It's just a list of URLs, and so it actually makes an image tag with the value of that URL. But if you go to styling visual attributes, you can go to, I think, the hover tool. Actually, sorry, I think it's configuring tools. Yeah, so that's I think a universal problem of like a hover tooltip is you can't. Right? There's a tap tool if you want to be able to have, so you could combine this with the tap tool where if you clicked on the point, it would go to a URL. That's definitely possible. Yeah, if you go to configuring plot tools in the user guide, down at the bottom there is custom tooltip. And that looks like this. In fact, I think this is actually the code for that example. It has the images URL here. And then it's just HTML, and you have, for instance, @images for the alt tag and @images for the source. And so it just shows the image, right? Because it just takes HTML. So that's a fairly simple way to get your custom hover tooltip. Okay. Let's see, what else to mention? There's this nice interaction you can have with Jupyter Interactors. So Jupyter itself, so Bokeh has a set of widgets that you can use outside of the IPython notebook or in the notebook, but Jupyter also has its own set of interactors, and Bokeh plays really well with that. Just as a quick example, here I create x and y. X is a linspace, y is sine of x. I put that in my column data source. I create a figure, I draw a line with x and y. And now what's my update function? So IPython has this interact function that takes this callback, and it will automatically create a GUI for you. So in this case, it's going to create a slider for f, for all of these different parameters in my update function. It's going to create this slider. Oh, sorry, I have to call it here. If I call interact, it's going to create this drop down for this, and so I can change this, and it'll update. Right? Or I can change this, or I can change the amplitude, or I can change the phase. And the way that works is, what does my update function do? My update function says, well, I'm just going to recompute the data.y, or data sub y equals amplitude times whatever the function is times omega times x plus phi. And then the secret sauce there is this push notebook, right? So what that says is update the existing plot, right? Whatever plot is currently, whatever plot is literally right here in this output cell, update that plot. So sort of push the data from Python to JavaScript, cause the actual plot that's rendered to update without making a new plot, just update the data source so the plot responds. So that's an example. If you look under examples how to, there's actually some other more sophisticated examples that show continuously updating plots, or if you want to sort of really have fine control, you might have noticed these things return this thing called a Bokeh notebook handle. That actually lets you control a specific output cell, right? So you can save those notebook handles, and you can actually push notebook to a specific output cell if you wanted to. But for basic usage, it's just something like this, where you call push notebook, and then the last plot that was output gets updated. So I've updated my source.data. I've updated the y values, and then I call push notebook, and that's what causes the change to happen. So when I move the slider and I compute new y values, all of them get updated. Okay. Hopefully that pretty whirlwind tour. Sorry. So you need Bokeh for the drawing. This pushes this, and to use push notebook requires the Jupyter notebook kernel to be running. And interact, I think in general, requires the Jupyter notebook kernel to be running. But you need Bokeh just for the plotting. You don't need like the Bokeh server for that kind of output. Bokeh has its own widgets as well. Just to mention this right quick, we'll see some more examples here at the end when we talk about apps, but I do want to give a little bit over time already. Here's an example. So from Bokeh.layouts, we want to import this thing called a widget box. Typically want to put widgets in this widget box. And I want to import a slider. Well, okay. So I can create a slider that has a start, an end, a value, a step size, a title, and I can just say show it. And sure enough, I get my slider here. So that's not too interesting, but let's go ahead and maybe try a few things right quick. Let's select and select. So you guys should try, everyone here, you all should try this. I think it takes values, if I remember correctly. Test my memory, values equals a list, so foo. I think, let's see if I'm correct. No, no title. Oh, comma. Outside the list is probably good. Value. Sorry, interesting. Okay. Okay, I'm gonna have to go look it up. So a good example to check out the options. That's it. Thank you. So Bokeh's gotten to be a very large library, and corners of it that I don't remember every detail. I was about to go to look up, but of course, it's also possible to do tab completion. Would have been another way to find that as well. So here's, I get my title here. And we get a nice drop down. So all of this is not so very useful unless we can actually do something with changes in state, change the slider and something happens. So what are the two ways to do that? There are two basic ways to do things with widgets in Bokeh. One is using something called a custom JS callback. And a custom JS callback is something that lets you specify a little bit of JavaScript, hopefully not much, 4 or 5 lines. In fact, there's actually a facility for compiling Python into JavaScript, but it's always important to note that the custom JS callback executes JavaScript in the browser, right? So using like pandas inside a custom JS callback is not going to work because pandas doesn't exist in your browser, right? So custom JS callbacks let you supply a little bit of JavaScript to get really rich functionalities. The other way to use widgets that we'll see at the end of the tutorial today is with Bokeh server apps, where you can actually attach actual Python callbacks running real Python code to these kind of events. And so, but let's take a look at some custom JS callback examples right quick. The first thing we're going to do is we're going to make a callback here. The code is simply some JavaScript code that says alert hello world. And I attach that callback to my tap tool. And I draw my plot here. And sure enough, if I click on if I use the tap tool to click on one of these things, it calls that JavaScript code. Alert hello world. So that's sort of the most basic usage of that. But there's a lot of places where you can add custom JS callbacks. All of the widgets can have callbacks added, when their values change, if the slider value changes, if the option on the drop-down changes. You can get callbacks when the selection changes. If you have a lasso or a box select tool or whatever, and then the selection changes. You can have callbacks when the ranges changes. So when pans the plot or changes, zooms and change the range, you can have callbacks on those as well. So all of these things you can attach little snippets of JavaScript to that go in your documents that can enable really rich interactions. So you can read about this sort of in more detail, but let's take a look at a particular example that's a little more interesting, which is this slider one. So what are we doing here? So I have my standard imports. I create x values and y values. In this case, I'm setting x equal to y, so it's just a straight line of points. The function y equals x. I put those in my column data source. And now I create a plot with a figure and a line. At the bottom, let's skip this for a second. I'm going to create a slider, and I'm going to set my callback to be this custom JS callback. I put both the slider and the plot in a column, and then I show the layout. And sure enough, I'll come back to the callback in a second. We see that here's my plot, here's my slider. If I move the slider, it recomputes those y values. So how is it doing that? Well, the way it's doing that is because in the callback, we're passing in the column data source as this args value for the callback. And that automatically makes it available to the JavaScript code. So I can say, get the data dictionary from my source. The callback object is whatever triggered the callback in the first place, in this case, the slider. So I want to get the value of the slider. And now I can pull out the x and y values. I can recompute, y equals math.pow, x to the f, x to the slider value. And then I can call source.trigger change. And that actually causes the plot to redraw itself. And so, this is a little bit of a compromise in terms of, having to write some JavaScript. On the other hand, it's a lot less. So with a little bit of investment in some JavaScript here, you can do some pretty sophisticated things like have these kind of updates. As a more sophisticated maybe example for selections, I won't go over this maybe in detail, but I'll show it. Need to import up here, custom.js, actually run it. This one I think is kind of cool. So here it updates when I make a selection. It recomputes the mean value, the mean y value of the selected points, and redraws where the line should be, right? So in this case, I've, even that includes even multiple selections, right? So it's computing the mean through that disjoint selection. So that allows you to do quite a lot of rich sort of interactions. If you go into the user's guide, again, Bokeh docs here. If you go into the user's guide on adding interactions, let's see if I can find it here. There is quite a few examples down at the bottom. for custom JS for widgets, custom JS for tools, custom JS for selections, and you can see lots of examples here. Here's a simple example that simply. So here's a custom JS for tools. I've got a drag tool, and I can just draw. I can sort of, if I want to add these annotations here, I can do that. Here I can select in one and have the data copied to another plot or manipulated in some way. There's the example we just saw. This nice one is a callback on a hover tool. I actually have some connected graph information, and hovering over it lets me expose and sort of actually draw those connected graph points. Let's see, range updates here. This lets me do a panning and sort of see a level of detail zoom on the other side. So there's a lot of kind of interactions that are enabled by custom JS callbacks. Again, they're going to require you to write a little bit of JavaScript, but we have quite a bit of information here in the custom JS or adding interaction section of the user's guide. There's also a new user's guide section that's completely new on extending Bokeh, and there's a lot of information about what exactly the JavaScript might look like if you go to some of this information on extending Bokeh. So we're not going to get to that today, but certainly happy to answer any questions on the mailing list or wherever. Yeah, question?
For the push notebook thing,
Yep.
can you have it corrupted just parts of the code?
So let me go back to, you mean this one?
No, I think it's even before.
This one?
Yeah, it's just the push notebook.
Oh, the push notebook one. Yeah, well, so what push notebook does is it says whatever the current state of Python objects is, mirror that in the JavaScript. So whatever you've changed since the last time you called push notebook, that change will get mirrored in the plot. So in this case, I've changed the data, so that's what changed. But it's possible you could change something else, right? I could say something like, what is it, p.title.text equals stir of func, right? I think that'll work. Actually, F is already that. I just do F, right? So I can just, F. And so now if I do that and I do show P, and now if I actually update this, I think it's going to update my title, right? Didn't do that. Where is it? Let's see, so p.title.text equals F. Go. Well, now I got to figure out why that's not, the title's not updating. But definitely, let's see, what else could we update?
Would it redraw the whole thing before you wanted to change the push?
No, so the way push notebook works is that's the whole point of push notebook is it's not recreating all of that stuff from scratch from JavaScript. It's really only triggering, it's changing just the diff, whatever's changed, and then causing updates to trigger.
3 data sets and redraw one of them, the other two.
Yes, will stay. Absolutely, yeah, exactly. Sorry, I missed that was the point of your question, yeah. Interesting. I need to figure out what's going on with the p.title thing there, because I know we have an example, for instance, if we go to Bokeh. If we go to the sliders example, I know that you can change the title there and that updates, so I'm not sure what I'm doing wrong off the top of my head, but we can go back and find that. It might be something to do with push notebook, actually. I might need to get an issue to investigate there, but should be the case that almost anything you change updates. And if you actually go to examples how to notebook comms, there's a lot of interesting examples there. There's an example where you're looping and continuously updating data, and you can see a plot sort of streaming data through. There's examples that use IPython interactors. There's a nice example that uses Numba and does some image smoothing based on a slider. So there's definitely some nice examples under examples how to notebook comms. Okay, so I think we're, like I said, a little bit over time. So let's go ahead and take another 5-minute break, maybe 10-minute break this time, and then James is going to take over and talk about some of the other cool and fun and awesome projects that work really well with Bokeh, and that'll be good.
Okay, so everything Bryan has talked about till now has been domain agnostic. You could be plotting anything, and nearly everything in Bokeh is domain agnostic. But there are a few domains that are special that have that it's difficult to work with if you treat them completely agnostically. And geographic data is one. There are a lot of conventions and standardized data formats, standardized way of doing things that are expensive to recreate bit by bit every time you do it. So for geographic data, we're only just touching it on in this tutorial. We're just pointing out that Bokeh is used by a lot of people for geographic applications. It's a very nice way to use that, because for geography, the thing about geography is it covers so many different scales, and so you really want something like Bokeh that'll let you zoom in and zoom out and pan all over the place. And the other thing about geographic data is that it's huge. Like Google Maps type data is very large, and so you very often don't want it all on your own local laptop or server. So So to support this type of data, the one thing that Bokeh, I guess, 0.11, not too long ago, added was tile source. And if you're familiar with how Google Maps API work, Google Maps work, basically, if you want to plot like this, covering a certain area of the world, Google and lots of other places, Bing, Apple has their own, set up a server that gives you data in tiles. So, if you ask for an area this size, Google will figure out that it needs to send you a tile, this one, this one, this one, and so on. That makes sense? And each one of these tiles, depending on your tile provider, is either an image or it's a vector object, and we'll focus on it being an image here. So if it's an image, it's a rasterized image with a certain resolution, and to cover the area you want to see, it needs to pull the standard one, the few that you're actually going to use out of its database, and these are pre-rendered as images. And so it's very fast for them to make a server to deliver that to you. They pre-render it all, and then you just feed them bit by bit to you. And handling all that is kind of a pain. But so we set up something called the WMTS tile source. There's a tile source that handles lots of different types of tile servers. But the most common one is WMTS, and that covers Google Maps, MapQuest, OpenStreetMap, and so on. And adding that to your bokeh plot is very simple, like disturbingly simple. If you create a bokeh plot, bokeh figure, if you just create a bokeh figure, in order to add one, you just do fig.addTile and add a WMTS tile source. And it actually will support any tile source anywhere. All you need to do is figure out the URL for it. In this case, we're using MapQuest. And if you can read that, this is not my machine, so. I don't ever use Safari either. I know, I'll show you that in a second, that's funny. So here I just had to specify MapQuest, and all I did is tell it, the way these tile servers work, they want to know your location on the globe in terms of, well, we'll get to that in a second, and a zoom level. And so you need a triple, and if you figure out the right URL, you can handle any tile server. In this case, it wants a zoom level, which will determine the resolution of these tiles, whether you're zoomed in a lot or so on. And then X and Y is actually in meters. It's in meters relative to Greenwich, England, assuming the world were mapped onto a flat plane. So it's a total mess, but it works. It completely distorts anything near the poles, but nobody lives there, right? So, okay, and depending on, one of the things you have to worry about, though, is the terms of service of the map providers. So if you go there, as of today, if you take if you zoom into MapQuest, if you zoom in enough, you get this. As of this morning, which is their terms of service has changed as of today, which is that they no longer give access to detailed high-resolution tiles. If you zoom out, it should work fine. At some level, obviously they've made a resolution-dependent decision on they're going to serve some tiles, but they're not going to serve their high-resolution tiles. But that's okay. There are many tile providers, and you would just type the name of another one. I typed it in ahead of time over there, but that's over there. You can use OpenStreetMap tiles. If you go to stamen.org, there are a bunch of tiles. Bokeh ships. If you look at bokeh.tileproviders, just look in that file. There is a long list of tile providers that have the right URL already formed for you. So you can use Google Maps, but if you do, you're going to have to pay them money. Because Google Maps API, you have to get an account with them, and you have to have some sort of contract with them that determines how many map tiles you can request. So we don't use Google Maps in any of our examples because we would be prosecuted. Everyone wants to see Google Maps examples, but if we put it up there, we're going to be serving Google Maps data, and we'd have to pay Google for the privilege of doing so. Stamen is free.
Yeah, just to be clear, the Google Maps class does now have an API key, so if you have an API key for the Google Maps API, you can provide that.
Yep.
And you can serve Bokeh Plus to Google Maps.
Yeah, it works. Technically, there's zero problem. It's only legal and monetary issues. But there are free tile providers. They're just not Google Maps. Yeah.
So if you wanted to prevent high-resolution images from getting blocked from your application you're making, could you specify a zoom level, and then if you zoom in too far, then the image is just pixelated or something like that?
You certainly could. We don't make that API available to you at the moment, but you could certainly subclass from W2Mesh tile source and enforce that restriction. But that would be at the Python coding level. You'd be modifying. Well, actually, you'd even need to change it at JavaScript level because all of this happens on the JavaScript side. So technically possible. It's not something we enforce right now. Today's the only day I've ever seen a message like this. It's a little bit crazy, but today is the day we need it. So. And obviously, this isn't that exciting because you can embed any reference to some external tile provider, not using Bokeh at all. You can just have some window that has that. But the whole point of this is to show your data in relation to geographic data. And so just to show that that is also very easy. So it takes one line to add this thing to your Bokeh plot. It also you can just add anything else to the same Bokeh plot, exactly the same as Brian's already been showing you. In this case, I created a data frame that has a couple of points. And here I wrote a little function that converts the meters from Greenwich into latitude, converts latitude and longitude into meters from Greenwich. It's just a little, it's an equation for an ellipsoidal Earth mapped onto a plane. But if you use that equation, you can take, I took Austin and New York City's latitude and longitude coordinates, plugged it through the function, and I get a data frame where I have X and Y, and those are now in meters. And now all we do is create a circle that has X and Y columns specified from this data frame, and we plot them, and there they are. And you can do anything you want on top of it. And of course, when you zoom in and out, those are going to stay in geographic coordinates. And you get the messages. Okay, make sense? Okay, well so we don't have time to go through it today, but there's an exercise at the end, which is pretty open-ended. It says, find some data in latitude and longitude. Plug it on top of this map. So just find some anywhere. It's fun, actually. You can, and you can change the other exercise, I guess, would be to change the tile provider to anything. That's an issue I've requested anyway, being able to lock the aspect ratio. I don't know the status of that issue. It's in progress. Because if you zoom over the image, you'll keep the aspect ratio the same. But if you zoom over the axis, so if I'm over here on this axis, the axis is very tiny. It's hard to see, but there is an axis there. It'll zoom this axis. You can do this in any Bokeh plot.
Yeah,
it's useful in other Bokeh plots.
The first thing to do would be to just make an option to disable the single axis zoom
Mm-hmm.
when it turned off. And then that's a very easy thing to do. So
Right. But usually in a Bokeh plot, this is useful because you can zoom your axes independently. For some types of data, you want to fix the aspect ratio. Yeah.
On the cross together notebooks, on the right of the thing that says like reset plot.
Yeah, that's probably over here somewhere. Oh, no, there's none in this case, but there usually would be.
Yeah, is that like a modification that you can make in like
When you create your figure, you can put the tool here. You can do reset.
Okay, great, thanks.
I mean, it might work.
Just to know, by the way, Google's standard thing, you got to.
Now it has reset.
But it's still 25,000 free requests.
yeah.
That's right. So we can't do it as an institution. You can do it individually as long as you have a small number of queries. As an institution, we would quickly, as every one of you used our online service to check out the examples, we would reach that limit very quickly. You personally may not reach that limit. That's fine. So yeah, Google is basically, you have to work that out. It's between you and Google to work out the terms of their API agreement. If you start involving us, then we get in trouble. We'll see. I was going to come back to that, which is that you can specify your polygons in GeoJSON format. Your polygons are points. For instance, if you have a shapefile that has all of the states or whatever, you can read that in easily and get a data source and then plot that. There are examples in the gallery. There's a chloropath. But if you see a picture of Texas, click on that one. I think that's at the end of.
Yeah, that one is using patches. We're increasing the support for GeoJSON is ongoing. But one of our contributors, Sarah Bird, is really interested in that, so she's hoping to be working on that.
And we also have a separate project that's in the background that we haven't decided that's about a possible commercial offering for geographic support that would be separately funded and so on. So there is interest in that, and there are people who are talking with us about funding that as so that may appear. We have no guarantees about that. But yeah, you can plot anything you want on top of this using any sort of low level, and there should be examples of how to do shape files, and it will improve in the future. I think there was an example. There was a link somewhere to the chloropath example, but I don't see it here. It's in the gallery, yeah. Yep. If you scroll over, so that's an interesting issue. The world is wrapped around as many times as necessary. So the world is cyclic, of course. So if you go around the world, you keep coming around again. But the data points are only at one particular location. So you'll see as many copies of the world as necessary, but the data points only exist at one. And we can make it work the other way. It's just it's not necessarily what you want. We could. And the other request that's already in there is to not allow zooming out so that you'll see the world twice. And that one probably is more useful. And I believe that's an open request.
No, but you can set bounds. Yeah, so if you want to prevent zooming out beyond certain bounds, that's doable. You can set bounds on the range. And we may at some point have a way to automatically duplicate points across multiple branches like that, but it's just something that was never part of the original.
But if you set bounds, can you still pan?
Yeah, you just can't pan beyond whatever the bounds are. You can set bounds beyond which you can't pan.
Okay, but if you're zoomed in, you pan
Yes,
bounds.
and you hit the bounds of the side.
Yeah, and in this case, you probably don't want that because that would mean saying there's one edge of the world, and that's discriminatory between anyone who lives over here and wants to look over here. So it's a bit of, as I said, geographic information has special issues and special conventions and special things to worry about, and so there's always more opportunity to respect those better. And obviously, there's work on projections that needs to happen because you see what happened to Antarctica here. I mean, that's ridiculously overstated in size compared to everything else. So you'd want to support other projections. This but nearly all the map tile providers only support this one projection, Web Mercator. Okay. Sorry. There are two answers to that question. The Google Map API, you can actually just look at the Google Map URL when you go to it, and you'll see this format, and you just paste it in. The other answer is that we also have a Gmap plot class, which uses. So there's an example of that on the web, and that's separate from this tile provider. The tile provider supports any tile provider anywhere. Which is very useful because it allows free ones. And the Gmap one only works with Google Maps.
Yeah, and to be clear, the Gmap plot uses the Google API, which I believe is part of their terms of service. I think if you just hit their tiles, like that URL, I don't believe that conforms to the terms of service.
You have to be able to supply the key, your API key to them.
The Gmap plot is a specific subtype of plot that uses the Google API and underlays a Google Map underneath.
And that's a vector map that uses vector
Yeah,
tiles.
the reason that's nice is because you can support all the map options you can pass to any standard Google Map. You can do, and you can change the look and feel of
Yeah, it's linked. It doesn't have a link here, but you can go find that. When I wrote this, someone else said that the tile source obsoleted, but Bryan points out that basically GMapPlot makes all the full configurability of the Google Maps vector tiles available. And so and that's because they're vector tiles. They are chunks of data where it has the data in it, so you can reconfigure whether you want things to be colored red or colored yellow or whatever. So if you do want to use Google, go for it. Go for GMapPlot. Anything else, tile source. Anyway, we expect more to be appearing in the GIS space. This is just the basics. Any plot you have, as long as you can manage to get it into Web Mercator format, overlay any data you want. No problem. All right, so the next, so any final questions? So the next section is totally different, which is data shader. And the reason this follows the geo one is that data shader is often used for geo applications. But how many people have heard of data shader? Okay, great. This is you're in the right place. Everyone else can hear of it now. So data shader is a completely separate project. It's hosted under the Bokeh PyData infrastructure, and it works very well with Bokeh, and is designed to work very well with Bokeh, and it came out of Bokeh. But it's still a separate project. It can be installed without installing Bokeh. There's no problem with that. And you'll notice in all the examples where you see Bokeh plots so far, we start out with a few data points, and sometimes you get a lot of data points, but you never get insane number of data points. And whereas data shader is at the opposite extreme. Usually when you want to use data shader is when you have so many data points that you don't see your points anymore. You see your distribution. You see, you want to have a faithful rendering of an entire distribution. For instance, this plot here is, this is just a very basic plot of census data. Every person in this plot shows up as 1 point, and if there are multiple people in the same pixel, that's a brighter point. So that's 300 million points in a certain size pixel array. You can't make out individual points for individual people unless you zoom in, and it supports that, but it's designed to faithfully render the entire distribution. And we have another example plot on the website from rendering 3 billion points. It takes a few seconds to render this. It takes a minute or so on my laptop for the 3 billion points, and it renders that without any problem. And then you can work backwards from just seeing all of the seeing the distribution back into providing a Bokeh style plot with full interactivity, and that's what I'll lead you through here. This is the New York City taxi data set here. This was 10 million data points from taxi pickups and drop-offs. Here it's colored red if it's a pickup, and blue if it's a drop-off. Sorry, at every pixel it's colored red if there were more pickups at that location than there were drop-offs. And that automatically highlights the thoroughfares where you can get a taxi compared to the neighborhoods where you get dropped off. And so this, it's designed to allow that sort of computation on the data where you can, you work pixel by pixel and work with all the data points that fall in that pixel. So hopefully that'll make more sense in a second. So when you, so you don't need data shader if you have a very small data set. Don't worry about data shader. It's probably more trouble than it's worth. And if you really care about rendering each individual points and be able to click on each one, interact with each one, you want standard Bokeh. But you do want to have data shader if you have plots that are too big for Bokeh or for Matplotlib or for standard approaches. And I'll say exactly what that means, why that is. And if you also want to consider data shader, if you've got data and you say, oh, I can't handle that many points, I'm going to subsample it. I'm going to look at every 1,000th point. If you ever find yourself thinking about that, think, oh, maybe I should actually use data shader. Because data shader will let you use all of your data points. You don't have to throw them away. You can use all of them. And so we'll show you why that works. So basically, okay, yeah, you can, that's up there. So why does that work? Briefly, just to remind you how Bokeh works, it's been implicit in everything so far, but you've got some data, and eventually you're going to get a plot out of it. What happens with that data is that it goes into some sort of Python object, and then it goes in from there into a JavaScript object, some HTML, JavaScript, CSS conglomeration, and then that gets shown to you as a plot. That makes sense? You got data. It is then we created some JavaScript, and that goes into your browser. So data goes from Python, and it crosses the Python Java browser boundary, and then it all goes over there. And because it's all over there, you can spit something out to HTML, and you don't need Python anymore. You can load your Bokeh plot that's been converted to HTML, and you've got it all right there. That's exactly why you can't handle large amounts of data, because it's all right there. What if you have 1 million points? Well, that's 1 million string representations in JSON of each number. And each number now becomes like 10 bytes or whatever, and there are 20 bytes per number. I don't even know what the number is, but it's exploded, and it's been encoded as strings, and it's all been given to your browser, which then crashes. So you don't want to pump a ton of data directly into your browser. So one approach is to downsample, choose a random sample of the data, and pump that into your browser. But this is the other approach, which instead you take the data, you figure out what you want to plot. This is just like in the charts API where we chose what goes on the x-axis and what goes on the y-axis. So we need to figure out, we got a bunch of columns. We need to say something goes on the x-axis, something goes on the y. And that at that point, there's something that in principle could be plotted. And then you create a raster. You rasterize that data. You aggregate it so that every little cell in here has a representation of all the data points that fell in that cell. Like let's say a common aggregation would be average or count. So if you do count, it will count how many data points fell in that cell. And at that point, you have a fixed resolution version of all of your data. Let's say this had 2 billion rows. At this point, you've got maybe 1,000 by 1,000 essentially pixels. It's not pixels because you can't actually see it. It's an array. But you have a fixed size representation of your data. And at that point, it's safe to put to the browser. Because it doesn't matter how big your data is, you've still got something only as big as an image. And that's all you're ever going to get out of it. Eventually, when it goes on your screen, it's no more resolution. There's no point in having a resolution higher than you can see. So however big your screen is in resolution, that's how big your image needs to be. That image can be rendered from your data. And at this point, let's say, so you take your fixed size representation, convert it into an image, and then you embed that in a Bokeh plot, and then the result looks just like a Bokeh plot. It is a Bokeh plot. It's a Bokeh plot that has an image in it that represents your data. But you could, have, for instance, have all these steps occur on a distant server, pass only that image down to your local client, and then you only ever see the image. You can interact with it just fine. It looks like a plot to you. So the final result of using Data Shader can look just like a normal Bokeh plot, but the process is just totally different. Instead of cram your data into the browser and do not crash the browser and let it show up, it's not downsample, but reduce, aggregate your data in some way so that it's visible, and then pass that reduced version, which is now, by definition, fixed size and a finite amount of data, pass that in and create a plot from that. So if you were doing, in this case, there were 300 million rows of data. In the end, we get 1,000 by 800 or whatever pixels of data, and that's what gets shown in your browser.
You mentioned we could zoom in on this one in the real one.
You can't.
Pre-sample on this new grid.
Yep.
Every time you zoom, and it has to recalculate on whatever server.
Precisely. So that's the reason why you wouldn't want to use Data Shader. Behind it, you have to have this machinery here, which is all Python. This is Python, 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 all the way to this point. And so once you have an image, you have an image. You can do whatever you like with that image. But if you want a new image at a higher resolution or you want to pan over, you have to go back to Python and say, I want a new image. Give me a new image at a new resolution. And so you need to keep your Python server around, or you can't. I mean, by definition, either the data's in the browser, in which case you've got it in the browser, and you can zoom and do whatever you like, but you have limited amount of data you can hold, or that it is not in the browser, and so you are saddled with this Python dependency. There's no, even theoretically, you have to choose one of these choices.
Can you use this outside of visualization if you're just trying to subsample your data?
Yes.
So
That's right. This is so Datashader is a library. It is not a plotting toolkit. It is just a Python library, and its dependencies are about running code real fast. So it depends on NumPy. It depends on NumPy. It has interface to pandas. It does not depend on anything to do with plotting. It'll generate an image. So it's just a pipeline from data to image, and then from that, Bokeh takes over after that. And so you can stop the pipeline before image, and here you get an array that has all your data in. You can do whatever you like with that. You can run statistics on that. You can modify that on that. It doesn't have to eventually turn into an image. It could turn into whatever you like. So this is it's all very much library-ish things to call from Python code, not things to interact with. And it's only at that last stage where we add the interactivity. That's right. So yeah, we have in this the difficult step is from the data to the aggregation. This is where you have to touch every one of your data points, and that's no matter what. If you have large data, that's going to be expensive, and that's what's heavily optimized in order to work quickly here. So, after that step, this stuff can be this can all be slow, and it doesn't matter. So and you can write lots of functions that operate on this data. You just write them very badly. They still are fine because they only have. Your data is only as big as your screen, so you can do whatever you like. But if you want to work at this level, you better optimize the heck out of it.
So could you plug in your, I mean, so that first step when you're doing the aggregation,
Yep.
do you have like a single algorithm, different algorithms? I mean,
It's a pluggable set of algorithms, and we provide some, and no one has yet needed to provide their own, but they could.
The thing I'm thinking is if you're using geospatial data, you might be doing some kind of R tree or.
Yep. Yeah. Yes. That'd be an example of where you'd want to write your own. It's not horrible, but it is. I mean, it's heavily optimized stuff designed to be very fast. So if you want yours to be as fast, you're going to have to do some effort in doing that. But it's I mean, the library is not huge. You can actually read the source code and see that the steps involved are not that complicated, but they're just the right steps in terms of performance. So if you want to have good performance, also be similarly able to do that. But you can write your own aggregation functions that are not high performant pretty easily. It's just that's going to be a big limitation. But that's where performance really matters. So let me show examples here. I won't show any of the cool examples because I don't want you to have to download tons of data. So I'm going to do a completely synthetic, boring, ugly example. All the fun examples, though, they're all on the website. You can download the data. It's a few gigabytes to get any decent-sized data set that is worth Datashader. So it's all available. You can get this data set and this data set. It's fine. Play with it on your own. I'll do a complete synthetic one here and show that. So I've maybe been a little bit misleading. I've shown that I've talked about the data size, but kind of the counterpart to data size is if your data is so big that you've never looked at the data points, your visualization is the only thing you've got as a way to understand it. And so if you do have big data, you must be very careful about how you do your visualization for it to be a useful thing, or not just lying to everyone on yourself. And here's an example. Here's something that doesn't use Datashader. This is all the same distribution, just different plotting settings, A, B, and C. And which one of these is the real data? Well, none of them, really. None of them are the real data. And in this case, this is a bunch of overplotted points. There's lots of structure to this data, but you can't see it at all in A. You can't see anything. In B, you can see there's structure. In C, you can see there's structure, but the structure looks quite different. So, all right, so let's see if we can visualize this using Datashader to address automatically. And the reason that'll work is that we're doing computations on the visualization. We're not just filtering at the data set level. We're not just doing image editing. In the middle, we've got this intermediate representation where we can do things like auto-ranging and auto-mapping colors and so on. So first, let's get this distribution. Here's the definition of this distribution. All it is 1, 2, 3, 4, 5 different Gaussian distributions, 2D Gaussians, 2D normals, humps. And they each have different locations. Let's see, they have different locations, different spreads, so narrow and not, and labels, and I have association value for all those points. You can ignore that. So if we look at the data set, here I said that there should be 10,000 points per distribution of 5 of them. So that's 50,000 points total. And here's the examples. They have locations. Every point is just drawn from these distributions. So it has locations, it has a category, and it has a value. So straightforward. So if we, this is actually what that distribution looks like in Datashader. Here's the code to produce this image. Notice that it's just producing an image. It's not a plot with axes or anything like that. Datashader knows nothing about axes. It's just going to give you an image, and we can add the axes later. And if you look at this, this is just the default visualization. So all it's saying is that I've got some data frame, and which I can't do anything without looking up. I've got some data frame. I'm going to plot the x and y for x and y. So those were the x and y columns here. And I'm going to create a canvas with the default size, whatever that was. And then I'm going to plot the, by default, it does a count aggregation. So whatever each one of these is a data point. You can actually probably see them. You can see that there are individual data points here. And it's doing, the color is darker if there are more overlapping data points. So just for every pixel, how many data points landed in that pixel? The more there are, the brighter it is. So it's a very simple model of visualization. You'll see that there are 1, 2, 3, 4, 5 distributions you can see. Here they're labeled. There's one, maybe you can see it up here. This is 10,000 points that all have very little spread. So it's 10,000 points that land in 2 or 3 pixels. This is 10,000 points that have a little bit bigger spread. 10,000 points have a bigger spread, 10,000 points even bigger, and in the background, centered on there is 10,000 more points. So that's 50,000 points. 10,000, 10,000, 10,000, 10,000, and 10,000. So at these 5 locations, right? Yeah.
So in a lot of these plots, there's been a lot of sort of auto-scaling.
Yep.
Looking at these, it looks like that color's pretty saturated. Like I can't really tell the difference between the bottom 2 at the most dense point.
That's right. Yeah, we'll go back to that.
Is there some logic to the way that auto-scaling is set?
Yes, we'll go back to that. There's a lot of logic to that. So it's a very good question. It's a core issue in the Datashader library, and it should be for everyone in general, but it's definitely a core issue for us. So we'll go back to how that's done and what, pros and cons and so on, depending on how much time we have. Okay, so this was just showing you the basic idea of what's in this data set. Now we'll take it more step by step. Here we're looking at, now we're trying to break it up into those steps that we saw at the start here. How can we see what happens at each step? We're kind of doing chunks of the steps to save time. So if we take that, what happens at the aggregation level? So if we take the plot, here we're specifying the width that we want, and this is the range in data coordinates. So basically, how big an image do you want, and how big an area in your data space will that cover? And that's actually the information you'll need to get a full plot later, because that tells you what your axes are. So as long as we keep track of that later, we'll be able to plot it. And then we'll create an aggregate that, we didn't actually need to specify this. We told it to count. That'd be the default, but you can do anything you like. Just like when you were discussing aggregates, it's the same things that are supported in general, mean, standard deviation, max, min, that sort of thing. Okay, so if you look at what your result of your aggregate step was, it's an X array. X array is very similar to a NumPy array, but it can have multiple dimensions in a nice way that have different data types. So it's which is important here. And you can easily convert that into a NumPy array if you want. Some chunks of it anyway. So we end up with a data array, most of which are 0 in this case because they're 0 near the edges. And this will show you that what's on each of the axes. This is just a list of some of the other aggregation operations or reductions that you can have. And so once it's in this format, you can see that eventually you can render it, and that involves what he was talking about how you map it to colors. But before you get to that step, while it's in this intermediate range, you can do a lot. which is, for instance, let's take this plot and only take X-ray support. This is just X-ray, so whatever X-ray supports is supported here. So we can take the aggregate X-ray and say we only want those pixels where the counts are in the 99th percentile. So throw away all the other pixels. So this is something that's calculating on your representation of your data. It's not anything about your data in its original form. It's about your data as you're about to see it. Throw away the places that are not densely populated enough with points. I don't care about them. Then you'll see it here. And if you were to zoom, it would rerun that at the higher zoom. Or you can run it through any function, including some that don't make any sense at all, like sine. Whatever it is. It doesn't matter. It's just data at that point. It's an X-ray that's full of data. You can do what you like with it. And when you're done doing what you like with it, then you have to make it into a color, which is what we're talking about here. Let's map it from here. This accepts any of the same colors that Bokeh does with the hex notation or tuples or names. And here we're going to map from dark red to yellow in terms of intensity. So the least intensity points will be where there's only one point, and so that's colored dark red. The highest intensity point is yellow, and it's mapped in between. How is it mapped in between? Well, if we map it linearly in between, you get a plot like this, where you can't see any differences in saturation. That's because the highest point you can't even see here. I can't zoom in, but in this version of it, zoom in later. But if there's one yellow pixel right here. Remember, that was where 10,000 of our points landed, right up there. So that one is labeled yellow, and then the next color down is dark red because there are 10,000 in that pixel. What are the next pixels? Well, they all have like 1 or 2 or maybe 50, very far from 10,000. So linear mapping doesn't work well with data with real data, let's say. We could take a log mapping, and sometimes log mapping can work fine. In this case, it shows you that these are more dense than this, which is good to know. Or we can take histogram equalization, which what that does is actually the default, which is it makes sure that each color, so you have a certain number of colors available. Let's say there were 100 colors that you can choose from. It makes sure that your plot has the same number of colors, pixels in color 1, color 2, color 3, color 4, and so on. So the very brightest ones, and that's why you're seeing here, there's not much difference between these very brightest ones. Partially that's because human beings don't perceive the color yellow variations in it very well. But the other thing is that there are not very many very bright pixels. There's one up here, very, very bright, and then some fairly bright ones, and then a few less bright. And so the total number of pixels out of this, the yellow portion of that has been allocated to that. That make sense? And so you have full control over how you want to do that mapping. Whatever you like is the answer. By default, it tries to reveal as much of the structure as it can, which is to do this histogram equalization. Just as an aside, this it's not just you can color things differently. Right now, here this is colored by that label that we put in. So here there was a category information. This was strings. There were 5 different strings, and if we use that to color to choose the color, you get this plot where the alpha is the number of points. So a very strong color represents a large number of points, but the color, the hue of that color is determined by the category. So these are things from the first distribution, second distribution, third, fourth, and so on. And so you can, but you might not be able to see that. There's a little function we add that spreads the value to make it visible. Don't need to go into that. Probably the more important thing is to show how it works together with Bokeh. For that, I'll rerun it here. Okay, so here what we've done is quite straightforward, really. We take and we write a function that recapitulates exactly what we did above. We did several steps, which was to aggregate and then color map So we created a canvas, then we aggregated into an array the size of that canvas, then we color mapped, and then you can get an image out. All we did is wrap that up into a function here. So we create a canvas, the right height and the right range. We aggregated. Here we're aggregating precisely the way we were right here. And then we colorize. And again, we're colorizing exactly as we were right here. There's a color key, by the way, saying that D1 is blue, D2 is green, and so on. And if we do that inside this function, and then we create a bokeh figure, and we add this, this is the bokeh figure P here. We pass that figure to this function interactive image. This only works in the notebook at the moment. Hopefully it'll work soon with the bokeh server. And we pass this callback function. And so all that does is create an image inside the bokeh plot that is now responsive. So if we enable wheel zoom, we should be able to zoom and pan, and if you watch, it has recomputed. Like here, this looks like one dot, but if we zoom in enough, see all the recompute. Each time that's data shader being called again as you zoom in, eventually down to the size of individual points. So this is fully interactive. It acts a little bit like a weird bokeh plot. Like it updates in ways that are unexpected to you as a bokeh user. But it's a bokeh plot, and you can overlay any bokeh data alongside this or whatever. You can underlay it with your map tiles, no problem at all, if this were in map coordinates, which it's not. And so you can see that in this case, you need the interactivity to even see that that was 10,000 points, right? You gotta, if you zoom out to here, it's just tiny, but that's the same number of points as you have anywhere else. When any sort of zoom or pan event is going to have to generate a new image, it's going to come back to you. This is all happening locally, but all of that server stuff could have been far away, and it would just send me a new image over the network every time, which is very fast, because you can load a website and see a web page come up with new images all the time, right? It's not that slow. So it's a very straightforward way to have a client-server architecture. This is just a handy thing we do. You can also write your own app, your own dashboard, there's an example dashboard that comes with it that doesn't use interactive image, that does it explicitly, that requests an image and gets it back. So you can do whatever you like. Yeah.
So I worked with some of the notebooks a few months ago, and you had to run Bokeh server to get this interaction to work.
That could have been before interactive image, but there's a dashboard example that comes with it that launches its own Bokeh server in the background, and you don't have to worry about that, and it interacts with that. And all of the other notebooks don't use Bokeh server. In fact, supporting Bokeh server is still in the future, because interactive image should work in the notebook and not in the notebook. Right now, it only works in the notebook because it's directly telling the Jupyter kernel to update this image. And so we'll need a version that doesn't do that. But right now, it doesn't use Bokeh server for this. Yeah.
Currently, you mentioned earlier that this requires Conda to install it. Is there a way to install it with Conda so that it will be available in a normal Python environment that is non-Conda?
I usually use Conda in a normal Python. I use Conda both in special Conda environments and also in non-Conda environments, and that's fine.
Install, can I import this thing with straight Python without activating the Conda?
Actually, I don't know the answer to that.
Do you mean like your system Python install?
Yeah, exactly.
I haven't seen my system Python in so many years.
Yeah, I know. That's just, I'm dumb and I do it that way.
So, the reason that we do it this way is because it depends on a lot of libraries like NumPy and LLVM. And so the easiest
Yeah,
way
but
to get.
I've got those.
Right, so in that case, I would say you probably just want to run a Python setup and install from the GitHub repo because it's pure.
That's right, yeah. Datashader itself is pure Python. It has nothing weird about it, but what it depends on, the reason it's at all fast is that it depends on NumPy, and it optionally depends on Dask to do parallelization and to do out-of-core operation. It depends on some very heavy-duty libraries with their own very heavy-duty dependencies. So this came up on the mailing list. Why don't we create a pip installable version of Datashader? And the answer is because I don't want to support everyone else's installs of libraries I don't maintain, like NumPy. It is hard to install NumPy yourself, not because NumPy is hard, but because it depends on C libraries. And even non-C libraries. So it's basically a chain of nightmares of installation that Conda takes care of for me, and otherwise individual users have to take care of, and they come to me and ask me to take care of them for them. So just one last bit about this. Here we created this distributions. Here there are 10,000. Let's just make that 1 million and run all for that. That should be 5 million points. I haven't run on his machine. Hopefully it doesn't cause any problems. Yeah, you can change it to, oh well, so I'm sorry getting data there. There's 5 million points. The data looks prettier, but it doesn't take any time to do because it's all being done. It's not involving your browser. It's just off screen in a buffer that is super fast done. It's all done. None of it happens in Python even. It's all happening in your low-level machine code. Numba's generating that based on the Python, and you can do that interactively. Now this is interactively zooming in on 5 million points. It just works super well.
Yeah, just to interject at scale, I mean, I've demoed the U.S. Census example at some other conferences, and we had it up and running, and that's 350 million points. And so we were going in, zooming in and out to different neighborhoods all over the United States, and the points for individual census persons randomized locations within city blocks, and it was self-selected race identification, and you could see sort of the different distributions all along different parts of cities at a very fine detail. So you could see like interesting details in Austin or other cities as well. But I mean, you could fully interact going in and out, see the full United States color maps into individual cities, and you could do that interactively, sitting in a conference display.
So this is now 50 million. I added one more zero. And now that took 3.5 seconds. So it does get, eventually it will get slow, but you have to get a lot. Yeah. Yes, not in this example, but if you go to there should be a link probably at the end there. So that, yeah, that's their 50 million points. Yes, extensive notebooks online show these, so you can go and see all the census data he was just talking about, and there isn't a filled out notebook in this one, but if you go to the actual repo, there is an example of doing hover data, and so hover data basically does a reaggregation. So if you've got an aggregation per pixel, you hover at a smaller aggregation level, and you'll find the data for that. So as you hover, move your pointer around, you'll get a summary of everything that's inside that slightly bigger box in a pixel. So hover works like that in Legends and so on. Basically, we have to rebuild everything from the ground up to provide interactivity. If you want hit testing, we can do that, but we're going to do that in Python. Bokeh's hit testing is in JavaScript. We need to go back to the Python thing, hit test, and then return the results, and so on. Yeah.
So as we zoom in, it doesn't rescale how the pixels.
That's right. So that's exactly, if you go to the online notebooks, there's no Python. So the export of it does pretty well, but it can't synthesize a Python server for you. So here's the online notebook for the census data. It'll have a live, here's a live, this is live, it looks live, but it's not live. There's no Python to do anything.
In my notebook of these dots.
If you've rerun it, it should scale. It doesn't. Interesting. Yeah, we can look at that because it did it here. This is just downloading from the GitHub repo, just like you. So that's interesting. I totally should have said data share was updated at 11 o'clock today. Because it did not support Bokeh 1.2. So it was ready 2 weeks ago. We set it up. It was beautiful. But then Bokeh came. There was a new Bokeh, and that broke it. So go to the README so that'll fix your problem. You need to go to the README, and where it says to install it, there's a different channel, a different Conda channel to get data shader from, because it hasn't propagated to the main Conda channel. So run that, and then it will work. Sorry, we worked hard to get it ready, but we didn't actually tell you about it. Okay, so it's probably time for a break, right? What was there a question? Okay, yeah, all right. Oh, one more thing to remember, we added special support for Bokeh, but if any of you are just considering Bokeh, it'll work. You can make your own little wrappers on this. The amount of Bokeh code in the data shader repository is very small. It's just putting these axes on it. So you can do the same in Matplotlib or anything else. It's independent. Thank you. All right, so we can finish the last bit. So the previous talk was about data shader, an add-on library that gives you data that can be displayed by Bokeh. HoloViews is an add-on library that is very different. It's basically an alternative API to Bokeh. It's a data science-centered API. It actually builds not just on Bokeh. It has a Matplotlib backend. There's the experimental Plotly backend. But for full interactivity, what is supported is Bokeh. HoloViews is it's kind of a different philosophical approach to these other libraries. Another library will say, I want to create a figure, and I want to put this here, and I want to put that over here, and I want to change the style of this, and the result is a figure. In HoloViews, it doesn't work that way. The result of whatever you do in HoloViews is your data. And then later on, as an afterthought, you get your figure. So I'll show you how that is. So it's data-centered, data science-centered, rather than plot-centered. And all the plotting has to happen. It happens behind the scenes, and it happens by Bokeh takes care of all that. So I'll show you how to use it and compare it to this, particularly to the charts API on Bokeh. So HoloViews has minimal dependencies. It doesn't have all these heavy-duty things that like data shader requires, and so it is available on pip. And if you use that, basically it's just like with Output Notebook. You have to have a cell early on that tells you want to use the notebook, and you also want to tell it that you want to have a Bokeh backend. So if you just change Bokeh equals false, that would be Matplotlib by default. And it'll show you that it loaded both HoloViews and Bokeh.js. So I'll first show very simple examples of standalone data, like a NumPy array, and then showed how to use it with pandas in a way that's like the charts API. So let's say we've written a function, and we want to visualize that. We want to look at a bunch of different phases, a bunch of different frequencies of this sine grading, and we want to sample it over a certain grid and look at that. If we do that, to do that, you just take the result of this call right here will be a NumPy array. Because if you go back to look at the definition of a sine, it returns np.sine given the arguments, right? And the arguments in this case are a NumPy array, so it's going to return an array where the sine function is sampled at lots of different points. And if you pass that to HoloViews and tell you want an image, you get an image with the default color map, which is this hot color map by default. It happens to be a Bokeh one. If I reran it with Matplotlib, it would be Matplotlib visualization at this point. The whole point of HoloViews is that this HV.image is not a plot. If you were to look at it and look at all the data structures, I mean, I guess, well, I won't mess with it right now, but it doesn't actually have any of the Bokeh information in that object itself. It's just something that interacts with the notebook's rich display machinery, so that when the notebook wants to try to visualize it, you notice that this is actually, unlike Bokeh, this is the output of this cell. So it returns an output that is this object, and when the Jupyter Notebook tries to visualize it, you'll get a visual representation. But if you weren't trying to visualize it, you could interact with it in other ways. For instance, because it still has all of your original data, it is your data in a nice little wrapper, we could take that data, here I didn't assign it to a variable, so it's gone. But here I create it again, and I add a little bit of metadata. Let's add the fact that it's a label, and then I get this object grading. That's just a Python object. It's not a plot. And I can take this Python object, combine it with another Python object that's a horizontal line in this case, and then use the star operator, which is compositional overlaying. So if I take that item and overlay it with a horizontal line at y equals 0, and I tell it, oh, I also want a histogram, and I want that laid out next to the same data, but sampled at y equals 0, sampled at this location. So the horizontal sample through an image is a curve. If it's a 2D object with a data dimension, you take a slice, you'll get a curve. And the result is a bokeh plot where you see your original data and the sample to it. And if you didn't want any of this, you could probably, well, I'll come back to that. So here, you'll notice that this grading object is not a bokeh plot because it doesn't make any sense to sample a bokeh plot. It makes sense to sample your data, at y equals 0. And so, with HoloViews, your data is kept as your data. In fact, insert cell below. Your data is just your original NumPy array. It's there forever. And sampling, all it does is select one of the rows or columns. And you can aggregate it, mix, min, max, whatever. Any sort of aggregation operator is also going to give you a curve and so on. And you can request the value at 0, 0 of this data, which turns out is 0. So you can see the result of that. Grading.data is just a NumPy array. This whole thing here, this entire chunk here is also just your data. Even though it looks like you're starting to become a plot, it's still just your data. Let's try assigning that to a variable layout. So this is your grading time overlaid with an H line, laid out next to a sample is some object. So what is that object? Your object is something, it's a layout. And then if you go inside that layout, you can see it's a layout of 2 items, a layout of an overlay and a layout of a curve. And if you go back to see, that's a layout of an overlay over here and a curve. If you were to, and this also shows that your data is indexable by x and y, and you'll get back a z. So you have an x and a y, and you get a z value. This is going to look a little weird because it's small. So everything's been zoomed in here, so you can't see the slider here. So one of the key things about HoloViews is because it's always your data, you can always do whatever you like with it. In this case, here let's create a bunch of these gradings with different y locations, and let's look at a sample at that particular y location. So here we've created a slider, and the slider moves the H line, and it moves where that sample is being taken. So the code for that, you notice, doesn't mention slider, doesn't mention interact, it doesn't mention anything. What it does is create something called a holomap, and a holomap is a multi-dimensional container that eventually, if you drill down enough, you get a plot, or something that can be plotted. But it's got a set of, in this case, it's just a one-dimensional container indexed by y, and that's what this tells you. It's got a dimension that's named y, and for every y, there will be a corresponding thing that can be plotted. The thing that can be plotted is just like this plot, but there's a whole collection of them, and unless you've sampled or selected one of those, you'll end up with a slider here. You get a slider because there are more dimensions than are on the screen. It knows what to do with some of the dimensions, put them on the screen. The other dimensions, it's going to pop up a slider. If it was indexed in 2 dimensions, and it knows how to display the thing in the middle, but it doesn't know how to display the other dimensions, you get 2 sliders. And so it's really set up to be, from a data science perspective, I've got multidimensional data and I want to see it. I want to see this bit and put it next to this bit and do all that. It's not about, Bokeh is really well set up by itself without needing HoloViews to have a plot and customize it and become the best plot ever. You can really do whatever you want about that plot. This is not talking about the plot. This is talking about your data. I want to see my data in all sorts of different ways of looking at it and slicing and dicing and arranging about the data. So it's a data scientist type workbench for dynamically creating the bokeh plot you want for a given set of data that you want to see. And so it's a very different perspective on how the data scientist wants to approach the visualization problem. Here's an example where we're indexing over 2 dimensions. Notice the code is basically the same. The only thing different is that we have a 2-dimensional map here covering different phase and different frequency, and automatically that shows up. And if we were to add a dot sample to the end of this, these would go away because we would have gotten rid of those extra dimensions that couldn't be laid out. But it's not, it doesn't mean you only have a certain can set of functionality. You have full control over all of the bokeh options involved. Anything you saw in Bryan's stuff where he showed you how to set a bokeh option, you can set that using this special magic. This is some IPython specific syntax that is a lot shorter than standard Python. You can also use standard Python, but what that tells you is that when you have any object of type image, you want to use this color map, red, yellow, green. If you have an object of type curve, you want the line dash. Here he showed you how to use, earlier he showed you a tuple notation. You can also use keywords. It's the same parameter. It's just anything inside these parentheses here is just going to be passed down to Bokeh without modification. It's just given to Bokeh. So it's a way to feed things down to the Bokeh plot underneath. Anytime there's a curve in this cell, it's going to become blue, and it's going to become dotted. Anytime there's a horizontal line, it's going to become white, and it's going to be wide, which is this one. And you can specify not just by type, but also I could have specified something for this particular sign grading by name. Each object has a name in its in this repr. You can see that it's an object that's indexed. Layout.overlay.signGrading will be some object, and that can be something I can set parameters on explicitly. But the options are set separately from the data itself. So this is your data. This is what you want to see, and these are options about how you want to see it. So these are kept separately. This is what you care about as a data scientist. This is how you make those onto the page. And there's exercise. I don't think we have time to go through there, but you can do that on your own. It's super easy. Just change any bokeh thing from the other tutorials, change it here and see the results on the plots. And you can combine multiple plots however you want. Plus is the equivalent of the equivalent of the row operator in Bokeh. Don't need to discuss this a lot, but when you have multiple plots, they can interact in certain ways, such as you can have them normalized together. By the way, these are live Bokeh plots. I mean, they zoom or whatever. They're just standard Bokeh plots by the time you see them. But anyway, you can have things normalized so they have the same constant value or not. That's just these are normalization options. And this now connects back up with the very first part of the Bokeh tutorial, which is, let's say we have that iris data set. In the charts API, this is what Bryan showed you earlier. This is how you look at a scatter plot for the iris data set. So it's a very simple API to look at that data. In HoloViews, you can have a similarly simple view of it. It starts out at the same level as the charts API. So you need to specify the same information. You still have to tell the plotting library what you want to see, and you get a very similar plot. But the thing is that it doesn't get very much more complicated than that to do very complicated things, which compared to the charts API. Charts API, anything that the standard charts API handles, great. It's really good for interactivity. You don't have to install anything else. It works. The HoloViews API allows you to mix and match and slice and dice and do whatever you like with that data. For instance, here's, if you want to plot things as color, you just, I first created this data set object and called it irises. And so if we take irises and we want to overlay whatever was on the, this is the dimension that's not shown on the screen by default. If we, actually I probably, so if we take that data and we call overlay, it's going to collapse species on top of each other. So overlay the species, and so that shows up in these different colors, which is what you saw earlier. But if we don't call overlay, so here's the overlay version, and if we just lay it out next to not calling overlay, what happens? Well, we've got your original data here, and you haven't told it what to do with this dimension, so you end up getting a widget for it. So by default, you give the widget because it doesn't know what you're going to do with that dimension. You just get to select that dimension. You just see whatever it is, not in terms of the plot itself, but in terms of your ability to choose which plot you want to see. So you can get it as a widget by default, or you can overlay it, or you could tell it to lay it out. I've got this extra dimension. What do I do with it? You overlay it, or you can lay it out. So lay it out, you'll get this. And you could do the same with any number of dimensions. So you can overlay and lay out anything, and whatever you have here, you can add it to, you can add additional plots next to it and overlay additional elements and so on. And so the idea is that you'll notice that there's nothing about plotting in any of this other than the basic idea of is in front of or is beside of, and then a hint, I want it as an image. But because if you want it as an image, you could also give it another hint, I want that as a set of points. You can convert any image to a set of points because the image wasn't a plot, it was your data. If you got dots as a curve, you can convert it to a bar graph immediately because points can be bar graph, or they can be a curve, or they can be whatever you like. At no point do you as the user interact with the actual plot coding unless you want to. If you want, you can just put a little call in there, you'll get a bokeh figure. And now you can do anything you can do in all the other tutorials, you just get the bokeh figure. But normally you don't need to, you just say, my data, and then the figure is created dynamically behind the scenes just for the notebook to consume. And so you focus on exploring your data. So this API is about you and your data and how to view your data, whereas the rest of the tutorials, including the data shader one, are about coming up with the best plot you can. So it's a different aesthetic, a different approach. Any questions? Okay.
One quick question.
Yeah.
I just noticed, looking over a couple of shoulders, a couple of people getting the raft of depreciation messages on title, text, color, and so forth.
Deprecation warnings for hollow views or for something else?
Yeah, it looked like hollow. Bokeh is one issue in this.
Okay, so hollow views also had to be updated for Python 1.2. That's been longer ago, but it may on the README file says a certain channel to get the latest version. Just like in this case, there's a special channel to get hollow views that has the changes that make it work with Bokeh 1.2. And the hope is that when Bokeh 1.0 comes out, not every other package that's based on Bokeh will have to update all the time. So, but in this case, they did. So if you go back to the README, it'll almost certainly address that. When you install it from the right channel, you get the latest data. Or wait a week, and it'll be on the main channel. So, the same applies. Or, yeah, wait a week, but then don't forget. Any other issues? Yeah. Live or line? The sample here, the curve here doesn't show the curve, but it shows the other ones. That's interesting. Did you install it from the regular channel or from the?
No, I just
Yeah. So I'll have to look at somebody's actual installation. That one is not one that I've seen. Anything else? Okay. I'll hand it back over to Bryan.
All right, so the first thing I would like to mention is that I forgot to mention earlier is that definitely be here sprinting. So if anyone's interested in working on things, then please, and you're available and want to get involved, please do stop by. We will be doing sprints for sure. So, okay. Okay. So last section here I wanted to go over was just some material about the Bokeh server. So if you weren't familiar with Bokeh or don't know too much about the history, this is something we've always wanted to have as this capability for the, to connect basically the PyData, the great amazing stack of, SciPy and PyData tools, Pandas and scikit-learn and all this just great set of tools to these interactive visualizations in the web. And so we had an original concept that we created and we learned a lot from it, but it didn't ultimately turn out to be maybe exactly what we needed. But we did have the opportunity to go back and invest in sort of a reworking of the Bokeh server. That was done at the end of last year, sort of a second generation Bokeh server, which is better in well, almost any measure that I can think of that we could talk about. It's easier to use, it's easier to deploy, it's much more robust and efficient and performant. A lot of the work was done by Havoc Pennington. If you know, he's one of the original authors of GNOME and GTK. He did just tremendous work. Very happy that we had his help on that. A lot of the layout work, by the way, was done by Sarah Bird, who's also really a tremendous contributor for Bokeh. It's hard for me to name everybody, but at least wanted to mention a few. And so, anyway, I wanted to show off some of the Bokeh server stuff and talk about the ideas behind how it works and see a few quick examples. There is this notebook here, chapter 8, on server. Note the big red thing there, the exercises require working outside the notebook. So the idea behind the Bokeh server is that you can write a very simple script. No special classes or anything like that required, just a very simple script where you create Bokeh widgets and Bokeh plots, and then you just sort of add them to something called a document. And then you run Bokeh serve on that thing, and you automatically get this deployable, scalable web application that sort of ties back to everything. So let's take a look. So the main thing that the Bokeh server is to do, I mentioned that at the low level there, this notion of models. These are really these objects. Again, they represent things like data or ranges or tools or the plot itself or titles or annotations or grids or anything like that. And there's a one-to-one correspondence between the Python models and the JavaScript models that we have that are inside the browser. And this is communicated via a sort of a JSON serialization. And that's actually, that decoupled nature is actually why we can have like our Bokeh and Bokeh.Scala and Bokeh.Lua. But for the Python case, the purpose of the Bokeh server is to keep those two sides in sync. If you make a change to the Python data source, then a session viewing that automatically updates in the browser, or vice versa. If you make a selection or a drop-down widget selection in the browser, then that's replayed back to the Bokeh server, and the Python copy of that document that's corresponding to that server gets updated. And you can have callbacks that do things like recompute things or do a downsampling or whatever you want. So let's take a quick look. So here's a simple hello Pi, and we're not even going to create a plot with this, right? So the first thing I'm going to do is I'm going to create import something called curdoc, which is the current document from Bokeh.io. And then I'm going to import, I noticed that that's out of date, actually. Row and column from Bokeh.layouts is probably a better idea, although HBox and VBox will work. And then I'm going to import some widgets. In this case, I'm going to import a text input and a button and a paragraph. And so I can create these. I can create a button that says label, and I can create a text input widget, and I can create this paragraph. And I can have a callback here. And so what does my callback do? The callback says I want to change the text of that output field to be hello plus whatever the input value was, and I want that to fire whenever the button's clicked. And then I want to put all of these things inside a layout, and I apologize that I apparently neglected to update this notebook. This would be like a column with a row and then all the widgets placed inside. And then the last thing here is we call add root. So let's go ahead and run that. So let me go ahead and open that up into a text editor, and we'll run it. And I'll get a tab here. And so if I go to like /temp and I vi hello.py, I'll insert all of this there. And now I want to go ahead and activate my right environment to source activate SciPy. And now if I do Bokeh serve -- show on hello.py, right, it goes ahead and it's going to bring up this web page, which has this button, and I say hello, and it prints whatever's in this box. So if I type, make that bigger, I'm sure why the layout there is a little bit off. That might be because I used the VBox, but it just updates, right? So it just keeps these two things in sync, right? I can attach a callback to the button, and whenever the state of the input box changes, I can change the output box from that. And I can open up as many copies of this as I want. If I go here, now there's another version of it, and I can put in, hello Bokeh. Let's make another one, right? Depending on what your application is doing, this is very, very scalable, right? So not spicy. Hello, SciPy. Spicy SciPy. Anyway, right? So this is very scalable, right? I mean, it depends really on the amount of work that the application does. If it does a lot of work, you'll need more running Bokeh servers to sort of scale out. But something like this, you'd need almost one to serve many thousands or more of connections simultaneously. So it really depends. It's hard to give any concrete advice, but the idea is always the same: is that we keep this Python side in sync with session browsers. Okay, so let's take a look at another example. If I can keep finding some other examples here. Okay, so that's our hello.py. So as an example here, you could take that, you could add a different widget there to do different things. So I'll leave that to everyone here. We're sort of running out of time, so we're just going to do some more demonstrations and explanations, hopefully, that are useful for you to go back later. Let's take a look at a little bit more involved example that has a plot and a widget. So we'll call this app.py. We import, random from NumPy. We import curdoc. We import our layout and our column data source. I have this function called getData. It just returns this dictionary that has random x values, random y values, random r values. So there's keys in this dictionary, x, y, and r. Each of those is just a random list of values from NumPy. I go ahead and I get one of those dictionaries and I set it as my data in a column data source. I create a figure here, tell it I don't want a toolbar. I create circles and I attach it to the x. Whoop. Where'd that go? Not sure what I did there. Some kind of IPython notebook thing. Apologies. Did I delete? I think I did. Okay, well, let me go ahead and shut this down and reopen the notebook. Go Bokeh applications. Yeah, I think I accidentally deleted something. Here we go. Right. So what did I do there? Okay, there it is. Great. So, so we create our figure. We create a circle, which now the x takes from the x column in the column data source. The y values are taken from the y column in the column data source. The radius is taken from the r column. We make sure to pass it the source so it gets used. We set a few other things. And then we add a select box that has initial value navy, but has all of these other colors as options. And we also have a text input, which has the number of points, which starts out at 200. And then we have two callbacks here, one that updates the color. So whenever the select box changes, it calls glyph.fillColor with the select value. Whenever the input box changes, it calls source getData with a new number of points, whatever the number of points was. Again, we put all of these things, this widget and this plot, in a layout, and then we add it to our document as root. So let me go ahead and copy this back into our app.py, except it's not going to let me, there we go. So I will go back over to VI here. It's my favorite, VI app.py. And I put this in and I save it. And I run Bokeh serve on now app.py. And sure enough, I'm going to get this nice, if I copy and paste it correctly from, there we go. Great, so that's exactly what we said. We have a bunch of random radiuses and random x and y positions. Right now it's navy, but I could select Firebrick, and so now they get reset to Firebrick because the callback that happens when I make a change in the select box is one that changes the glyph fill color value. We change it to black, we can change it to olive, we can change it to goldenrod. What a great color goldenrod is, one of my favorites. We could change the number of points, right? So this is 200 points, but we could certainly have 2,000 points, right? We could even have 20,000 points, not too bad. So kind of weird there. But yeah, so this lets us have these responsive apps. And again, we can open up as many connections as we want. If you needed to write sort of a more intensive app that did more work and you wanted to have it scale out, obviously there might be more considerations. You might want to run multiple Bokeh servers. It's very easy. So the way the new Bokeh server is architected is it's very horizontally scalable. Basically, if you need more capacity, you just run more. You can put them behind a load balancer. You can run multiple threads on a single one if you want. It's much easier to sort of scale out. And we actually have an example of a full deployment if you go to demo.bokehplots.com GitHub repo under the Bokeh organization. It has an example of the exact site that I showed you earlier, that demo.bokehplots.com site. That's the deployment we use. So let's see. So there's an example that changed those things. Again, we can open up multiple versions of them, and you'll notice that each one is individual, right? So this isn't the same set of 200 random points. Like every time a new version of this application calls up, it calls that getData function, which gives it a new set of random points. So these, in this particular case, it's a set of running code per session here, or a set of a document that can be synced per session. Okay. Question? Yeah.
Is that all the same for all those tabs?
Yes. In this case, it's all /app, right? So I've only run one. So if it's possible, so I called it app.py and I said Bokeh serve -- show app. So it's called app. But you could call it whatever you want. In the previous one, I think it was called The default port is 5006, but you can set it to whatever you want. That's configurable depending on what you're doing. If if you're just running it by itself, you might set it to port 80. If you're running it behind like Nginx or Apache, which is certainly very common if you want to actually deploy something to the wider world, probably you probably want to put it on some special port that's behind your Nginx or Apache install. Okay, so let's see. Last example here. So we're running out of time. Go back to server. Is streaming data, and this I'll say very quickly. There is an API for streaming, which is really nice. So again, import some things we have here. We import sine and cosine. We import curdoc and our column data source and our figure. I'm going to create a figure. I'm going to add a circle to it. In this case, that's x equals 0, y equals 0. I'm just adding a single sort of point to it. Sorry, in the center. And then we add another circle here that takes x and y from the column data source. Right, so x equals x, y equals string y. This is the column data source here. I'm configuring it with one point to start off, just to have something to see when we start this. And now I'm creating this update function, and I'm updating the very end of, I'm sort of rolling the data over, right? I'm updating source.data x minus 1. Let's see, rather, I'm getting the last point here, sorry. And then I'm appending that data to a new dictionary. It has just the new points that I want to add, and then I call source.stream on that new dictionary. Let me actually show you what it does first, then we can come back and look at the details. But then I add this update as a periodic callback. I want it to happen every 150 milliseconds. So if we go ahead and call this, we'll call this stream.py. Put that in there. And now if I do bokeh serve stream.py, what happens is it starts moving the number of points around sort of the edge of that circle. So what happens is that you want to update only just the marginal difference in data. That's why this is called the streaming API. You can always just change the entire data dictionary in your column data source, but that will always send all the data. So if your column data source has columns that have 1,000 or 10,000 points, and you just want to tack on one new point at the end, it's very inefficient to send all of the data points. So this stream API lets you send just a marginal new data point, right? And so that's exactly what happens here. We go back to this. So here I'm constructing this new data, which only has a single new point tacked onto the end, right? It's got an x position and a y position, and I'm appending that to passing that to the source.stream function. And I'm not passing all of the data, just this one new point. And the rollover equals 8 means that as soon as the number of data points in the browser gets to 8, we start dropping points off the beginning. And so that's why it sort of rotates around. So we could change that. If I go here, for instance, to this application, and then I edit, we can change rollover to, I don't know, what's a good number, 20? Change rollover to 15 maybe. And so now if I run this, it'll start keeping more data before dropping things off. So again, you wouldn't want the data in the browser to grow without bound, typically. So if we do this now, you can see that now it's going to keep 15 points before it starts dropping off the points at the beginning, right? So that's all that rollover means. It just says how big a buffer do I want to maintain in the browser. Maybe so. So what's actually probably going on here is that I think my aspect ratio is not very good. So there's an issue with circles. This is something that's come up a few times, which is that if your aspect ratio is not 1:1, you have to choose a direction to measure across. And so in this case, the measure by default is along the x-axis. And so this circle is probably not exactly a circle. So if you want to make that circle exactly a circle, you would need to orchestrate it so that the aspect ratio of the internal region is exactly 1:1. And we're about to add some support to make that easier to maintain, but you could do it right now by hand. I just haven't done it. But yes, very good point. But the x and y positions for the markers are just whatever they are, right? There's no radial symmetry to care about there. But this is something that's come up. If you were to, I guess, as a more stark illustration of this, let's see. Where we create the figure, let me do plot width equals, let's do plot height rather. So this is a consideration to think about, right? Sometimes things are a pain. So this makes it taller. So it's measuring the circle, right? Because it doesn't exactly fit in there, because it's measuring the circle along one dimension. But the aspect ratio for the central area is not. So you can make it so that the aspect ratio is the same. It's a little bit of a tedious right now because you have to specify basically min borders along all sides so that they're large enough to accommodate all of the axes labels and such, and then you will get the center area 1:1 if your outside area plot sizes are 1-to-1. So that's a good question. Thank you for raising that. Okay. So last thing then, maybe just to show a few things. I don't have time here. We didn't add a section. It's possible to use custom extension models with Bokeh. As an example of that, I actually wrapped a completely separate JavaScript library for 3D visualization. I think it's called viz.js. And I connected that to a Bokeh server app. So this is a nice application that lets us have this custom model. So there's no 3D support built into Bokeh, but because I wrote a custom model, I was able to do this. And the code for this is actually quite short, right? So if we look at the source code, the main.py here, very short. I basically create a column data source with X, Y, and Z fields. I stream X, Y, or I compute new X, Y, and Z values that I simply, set every update, and that causes the JavaScript side to be synchronized automatically. And then the custom extension looks something like this. Well, so there's a Python side, which the main thing it does is it points to some JavaScript code. It defines some properties, X, Y, and Z, and it points to this JavaScript implementation. And the JavaScript implementation is, let's see, what does it look like? It's actually CoffeeScript, but there's a lot of comments here so that people who want to follow this can know what they're doing. But the main thing is here, it takes the X, Y, and Z values from the Bokeh, Python code that gets synced automatically to JavaScript and puts them into the viz.js API. It's just a translator. So you can wrap all kinds of JavaScript libraries this way. That's why I said the whole idea about making Bokeh extensible is that we want people to be able to move forward without having to wait on us. I want to help people make all kinds of extensions. I want to make extensions very easy to share amongst the community. And that way I think there'd be a lot of ways to push things forward that they don't necessarily have to wait on us. So that's good. Just a few other last examples to show off here. Here's an example. This is a kind of a replica of an R example called the Shiny Movie Explorer. I think this is actually a really performant version of that. So we can sort of take a look, and you guys could go to demo.bokehplots and play with this if you wanted to. Sort of look at different ways to slice and dice this data. Another one here is this nice cross-filter one. I think I showed this earlier, but I like this one a lot. This again is the MPG empty cars data, and we maybe want to color it by displacement or size the circles by weight, and we can do that sort of thing. And so this was less. All of these examples, I believe, every one of the ones here is less than 100 lines of Python code to have these deployable, scalable, interactive data visualization applications backed by PyData and SciPy tools. So that's sort of the takeaway. Any last questions?
Right now, to render these, rendering to PNGs, is it
Yeah, so right now there is a save tool that lets you render to PNG. I don't have one on this plot, but basically when you click on it, and it either, depending on the browser, it either offers you to download a PNG immediately of the canvas, or it just opens a new tab with that image as a PNG that you can save. The next step is I believe we have a path for saving SVGs, which is an immediate improvement. Programmatic generation is maybe a little bit harder, but we'll see how we can maybe use Phantom.js or something to try to make that happen as well. But that's definitely a priority for us, especially as we bear down on sort of a 1.0. It's I think we finally have the pieces in place to get towards that. So, yeah. Question?
So to use Bokeh with an existing Django cluster SQL database, I would do what? To point it to custom template of the.
So yeah, so the question is how to integrate with the existing thing. So one thing I forgot to mention is like this actually uses there's a couple of answers here that are worth mentioning. It's possible to have a custom template for Bokeh app, and this one does that. So for instance, if you're wanting to have like basically a single page application that's very heavily centered around these kind of interactions and these widgets, it's really easy to do it just directly from Bokeh server, and then you can scale it out behind your load balancer or Nginx or whatever. If you want to embed Bokeh applications into existing Django or Flask or CherryPy applications, that's possible too, but that's a little bit more of a sophisticated, advanced kind of topic. I'd suggest you come by the mailing list and we can sort of have a longer discussion. Iframing also works really well too. If you go to the 012 announcement for Bokeh 0, it's Bokeh, we have a new, other announcements. This is good. Bokeh.github.io. A very new site here sort of for the Bokeh GitHub organization, including a blog with all of one blog post, which I'd love to have contributors, right? It's really easy to add content for this blog. I'd love to get more people talking about what they've done with Bokeh, so please let me know if you'd love to contribute to this. But anyway, this has, sort of this examples of some of these, layout things that are right here that are really nice. But it has this iframed app, right? I mean, this is that app just iframed in here, and it works really great. So if that's an option for you, it certainly works really well, and people have done that. And then there's also a new JS API I should mention. But yeah, so just in terms of the responsive stuff, as long as we're here, the nice thing about this is that it sort of does respond in a nice way. And so that's a lot of the new work is centered around that type of responsiveness. Okay, any other last questions? I know we're a couple minutes over time. I appreciate everyone hanging in there with us. Last thing I mentioned, there's a happy hour Thursday. If anyone's interested at the Continuum offices, please come by, just check Twitter. I know there's information on it there. Come by and say hi. We're happy to talk about any of our projects or open source projects, and that'll be great. Otherwise, I said we'll be here for the sprints, so I would love to see anyone and everyone who'd like to work on Bokeh, and thanks for coming.